Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you. So everyone can hear me. Good morning, ladies and gentlemen. My name is Karnita Yuniarti. I will be your moderator for today. I will be accompanied by my colleague, Dr. Imran Sofianto, from the STEM. We are from the STEM Research Center for Biomass and Bioproduct. We will be your moderator for today. I will chair the session, invite a speaker, and the next paper presentation session after lunch. And then afterward, Dr. Imran will take the role as moderator for the last two paper presentation sessions. With a great pleasure, first of all, allow me to welcome our invited speakers, Associate Professor Dr. Hajwan Hussein and Dr. Guo Huan, all presenters who will be presenting their work today, and all of participants to parallel session 3 with the topic on wood industry and forest. Today, we are going to have speech from our invited speakers and 17 papers presentations. We will divide our parallel session into 4 parts. The first part will be speech from our invited speakers, and the other parts are the paper presentations from presenters. For each part, there will be question and answer sessions at the end of every session. So please keep stay in each session to answer any question from the presentation until the end of your session. Before we start the sessions, I would like to remind you that we would love to have an interactive session between the presenters or speakers, participants. So we invite all presenters to turn the camera on once we start introducing you, when you deliver your presentations, or when we play your presentation video, and throughout the whole Q&A sessions. For the participants, we also welcome you to do the same. However, if you are too shy to turn your camera on, you may use the raise hand button on your screen to deliver your questions, as we will turn off the chat room once we start the Q&A session. For the best audio quality, we recommend you to use any listening devices, and since this is an online forum, you surely may enjoy the session together with your colleagues at work or family at home. The second ICONLIG 2022 can also be accessed through our official YouTube channel. So you and your colleagues or family can also stream our event live from your phone, PC, tablet, or laptop. Now let us start our first session, which will be a speech delivered by our two invited speakers. First, we have Associate Professor Dr. Muhammad Hajwan Hussein from the University of Science Malaysia in Malaysia. Welcome, Dr. Hussein, to our session. And second, Dr. Guo Huan from Research Institute of Wood Industry, China's Academy of Forestry in China. Welcome to Dr. Huan. Allow me to firstly introduce Associate Professor Dr. Muhammad Hajwan Hussein as our first invited speaker to everyone in the room. I will read his short bio first. Associate Professor Dr. Muhammad Hajwan Hussein received his BSc honors in chemistry and MSc degrees from University of Science Malaysia, respectively. He was awarded double PhD degree program with USM and University de Lorraine, France, and also was awarded the Best PhD Research by Institute of Postgraduate Studies, USA. His research area involves valorization of lignocellulosic biomass for advanced material applications and corrosion protection. He was listed as top 2% scientist in the world under the category of 2019 and 2020 citation by Stanford University. He is also a research fellow at CGeogTech, UNIMED, and a visiting professor at the Université de Lorraine, France. He has published more than 150 papers of his research work in reputable journals and also presented many scientific papers in various conferences nationally and internationally. He is an associate editor for Frontiers in Chemistry, Green and Sustainable Chemistry, and review editor for Frontiers in Materials and Environmental Degradation of Materials. So Dr. Hajwan Hussain, we already have your presentation video with us, but since you are here, would you like to, to give presentation live by yourself? Or would you prefer us to still play your video?
Hello, everyone. Good morning. Thank
Yes.
you. I guess maybe you can play the video because
Okay.
I guess the presentation is just 18 minutes
Okay.
and we have ample time for more questions. So,
okay.
Yeah.
Thank you, Dr. Hussain. Okay, so ladies and gentlemen, let's now watch the video from Associate Professor Dr. Hussain, who has prepared this video since a couple of weeks ago. Without further ado, I would like then to request our IT team to play his presentation video. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Welcome to ICONLIG conference. I would like to introduce myself. My name is Muhammad Hajwan Hussain. I'm currently the Associate Professor in the School of Chemical Sciences, University of Science Malaysia. And I would like to thank the organizing committee of ICONLIG 2022 for inviting me to this conference. And what I'm going to share with everyone today is basically my research, which we have done in several years. And the title of today's presentation is Elucidation of Oil Palm Based Lignin as a Substitute for Wood Adhesive. And before we begin, I guess maybe it's best to introduce to everyone about lignocellulosic biomass. And we know that this biomass is actually derived from living or recently living organisms, and it could be coming from plants and plant-based materials. And some statistics have shown that lignocellulosic biomass actually occupies more than half of ocean and land. So that's actually show how much this biomass waste been produced throughout the year. And then it has been said that this biomass could be one of the promising source of renewable energy. And looking at the name itself, lignocellulosic biomass, we know that the main component of this biomass is actually cellulose, around 30 to 50%, hemicellulose 20 to 30, and followed by lignin around 10 to 30%. The current trends of utilizing lignocellulosic biomass into fuels of chemicals have been largely studied, and this could be done by employing thermal and chemical or biochemical methods. Therefore, the main concept in biorefineries is basically when you have lignocellulosic biomass, it will be first treated in a primary biorefinery. So this pretreatment is actually important to separate the major component of lignocellulosic biomass. You can have cellulose, hemicellulose, lignin, and then after that, the secondary biorefinery actually refine all these components into a more refined structure, such as furfural, vanillin, and whatsoever. And these refined chemicals can be used for further applications. And the work that we have done quite recently is more focused on the oil palm biomass. We know that Indonesia, Malaysia are actually the highest contributor of palm oil products. And for Malaysia alone, due to massive activities in palm oil industries, it actually generates around 50 million tons of lignocellulosic biomass waste every year. And from this oil palm biomass, we can actually categorize it according to their parts. So you can have anti-fruit bunches. After they press, they actually discard the bunches, the empty bunches, and this actually around 4 million tons per year. And we also have oil palm fronds, which normally prune during the plantation, and then the degeneration of OPF is around 24 million tons per year, quite high as compared to the other types of biomass, which is actually oil palm trunk, which normally around 3 million tons per year. So our work normally focus on OPF, but we also tried with other oil palm biomass waste as well. But as I said, I think the work that I'm going to share today is more or less related to OPF. And to separate the major component, as I said, we need to do the pre-treatment. So some basics of the identification process need to be understood. The purpose of the identification process, or some people call it as pulping process, is actually to separate the components of wood into lignin, hemicellulose, and cellulose. This technique has been largely used in paper industries. In Scandinavian countries, they are using pulping methods in order to produce pulp and paper. And the resultant product are actually pulp and also black liquor. So the black liquor actually very rich with lignin and hemicellulose, meanwhile the pulp is actually very rich with cellulose. The delignification process can be done using high pressure and high temperature reactors with the addition of some chemicals like alkaline and some organic solvents with a known solid to liquid ratio. And some basics of pulping process, we have I think alkaline process and organosoft process. So for Kraft process, the types of chemical used is basically sodium hydroxide and also sodium sulfide. And this chemical actually produce, I think, sulfide functionalities into the Kraft lignin. The working temperature is around 150 to 180, and time is around 1 to 3 hours. So it's quite a severe process. Meanwhile, for soda process, it's almost the same, except that the types of chemical used in this case is only sodium hydroxide. Working temperature and time is almost the same, and this actually could produce around 20 to 30% of lignin yield extractive after the process. And finally, we also did some organosoft process. And in organosoft process, what basically we are going to use, a mixture between organic solvent, which in this case we are using ethanol mixed with a certain percentage of water in the presence of a small amount of organic acid and or mineral acid. And then what happened is that the temperature is slightly increased around 150 to 190 with a working temperature quite a short time, around half an hour to 2 hours. The comparison between the pulping process, maybe you might wonder what's the difference between the quality of the lignin obtained. Obviously, when you extract the lignin using alkaline process, you obtain more condensed structure as compared to the one that is isolated using organosoft method. So the organosoft method produces a lower amounts or yield of lignin, but it gives a slightly better properties in terms of the solubility or antioxidant activity rather than alkaline process lignin. And talking about lignin, maybe some of you don't have any idea what is actually lignin. So lignin is actually a polyphenolic compound composed of major phenylflavonoid monomers, paracomeric alcohol, guaiac alcohol, and stringent alcohol. So it's actually considered as a waste product of pulping and bleaching process. Lignin is actually not toxic, complex in nature, and it is actually natural phenolic polymer. And some recent studies have shown that there's an increase in importance in many applications, such as the use of lignin as a binder, dispersant, emulsifier, corrosion inhibitors, antioxidant, and whatnot. The work is actually more focused on wood adhesive. We know that the common types of wood adhesive available in the market is actually formaldehyde-based wood adhesive. You can have phenol formaldehyde, urea formaldehyde, melamine urea formaldehyde, and whatsoever. So urea is considered to be the raw materials in resin production. This is because it has these aldehyde functionalities, but certain exposure of formaldehyde into human can cause several threats, because we know that this type of chemical is actually carcinogen. At certain limit, it can actually cause irritation to human, and even it can cause cancer. So some other alternatives that we did in the current study was to replace formaldehyde with a less toxic aldehyde, which in this case glycoside. So glycoside is actually the dialdehyde. So function as the same, I mean, to produce a cross-linking with the phenolic material, but it gives a more safer, I think, properties as compared to formaldehyde. The basics of resinification process for lignin-based adhesive, we consider lignin as the substitutes to phenol, because all the time phenols are coming from petroleum-based industries. Sooner or later, there will be a depletion of these chemicals. Therefore, what we have proposed as well is actually to replace phenols with lignin, and at the same time replacing formaldehyde with glycoside. So in the end of the day, we are producing a more green, less toxic wood adhesive. The basic concept of resinification is the same. You have active reaction sites in the lignin structure, mainly for guasil and also for H functionalities. Then all this condensation or the formation of methylene bridge can be formed. People have studied lignin-based wood adhesive, I think, in many years. And what they did was they tried to isolate lignin from different biomass, and then they formulate it into a different wood adhesive. So depending on the types of lignin that they obtain from different biomass, it will give different properties in terms of mechanical properties. And I think so far there's a lack of study that actually use dialdehyde or glycoside in replacement to formaldehyde. Therefore, in our studies, what we did was we isolate the lignin from oil palm biomass, which in this case more specifically on oil palm fronds. And then the oil palm fronds basically was cut into small pieces, and then it will be grind. And after that, the ground OPF powder will be subjected into pulping reactor. So we did different kinds of pulping process, but in this case, we are actually focused more on craft and also organosoft lignin. Meanwhile, after we obtain the black liquor, we precipitate it, and then we obtain lignin. We characterize it using a normal physicochemical characterization, and we also did the resinification process. So the resinification that we did in our study is actually by substituting different percentage of lignin with phenol, and at the same time, we replace entirely formaldehyde with glycoside. So certain percentage of the 10, 30, and 50 substitution, lignin substitution be used. And we are also using some small amount of catalyst, base catalyst, and also the solvent that we use is actually ethanol. And some might wonder why we use ethanol, because using ethanol as compared with water, it actually provides faster curing as compared to water. So that's basically the main reason why we replace it with ethanol. So after we obtain the resin, what we did was we concentrate it, and then we apply it on the plywood. Okay, so it's a 3-layer plywood following a standards, and then after that it will be cured using hot press, and it will be cut into a different dimension. This is also following a standard ASTM standards and subjected to UTM machine, universal tensile machine, to study the tensile properties, modulus of elasticities, and internal bonding. So the wood adhesive properties that we have studied, actually we look at the solid content, viscosity, gel time, and also pH. And as we increase the lignin substitution, we observe that the viscosity actually increase, gel time become faster, and also the solid content become higher. So this is actually in a good agreement with other findings as well. And surprisingly, what we have obtained was 50% of organosoft lignin phenol glycoside produced higher solid content, higher viscosity, and also a shorter gel time. So the resin was further characterized using some complementary analysis. For example, using FTIR. So what we have determined over here was the formation of a methylene bridge. So it means that the cross-linking process actually is successful, and this actually supports that the formation of cross-linking bridge depends entirely with the content of HGS ratio. And the other thing was we also characterize it using carbon NMR. So from the carbon NMR, we also detected the methylene link, cross-linking bridge, as well as other functionalities with regards to methyl groups and other things. We also proceed with a thermal analysis. So from the thermal analysis, what happened was, as we increased the percentage of lignin substitution, the delta T, the change of temperature, is actually decreasing. So lower value of delta T indicates higher rates of curing of resin. It means that the curing will become faster. And it so happens that 50% of organosoft lignin phenol glycol produce the lower delta T values. And finally, we did mechanical properties. So the panels was actually tested, and we actually did for dry condition and wet condition. For dry condition, we observed that 50% of all organosoft lignin phenol glycol produce higher tensile as compared to the other percentage and also the control. Meanwhile, in the wet condition, so wet condition means that the panels soak in the boiling water and in several hours, and then after that we dry it and subject it to mechanical properties. So even though some percentage show some delamination, but 50% of organosoft lignin phenol glycol still shows a better tensile properties. And we also did some comparative study between 50% of organosoft lignin phenol glycol with a commercial PF resin. So what happened was it showed some tremendous increase in, for the lignin that adhesive that we have developed as compared to commercial PF. So it means that it's still acceptable to be used in industrial application. So as a conclusion, what we have found out was smaller fragments of lignin obtained from the organosoft pulping process produce a higher phenolic OH content, and this higher phenolic content actually contributes to more reactive sites for the cross-linking to happen. And the higher mechanical strength of 50% of organosoft lignin phenol glycol was probably due to a more cross-linking, as I said earlier, because of higher phenolic content for organosoft lignin phenol glycol resin structure. So to end, I would like to acknowledge my university, University of Science Malaysia, for providing research grant, and also our contributor, our collaborator in this study, majorly coming from France, Université de Lorraine, Professor Nicolas, Isabelle, Laurent, and also Francois, and some other collaboration with BRIN, named researcher Dr. Widya, Dr. Firda, and also Dr. Adli. We actually published some review articles together, and I would like to acknowledge my students as well, who've been working a lot in developing the wood adhesive from all biomass waste. So with that, thank you very much for your attention, and I'm happy to answer any of your questions. Thank you and terima kasih.
Yeah. Thank you, Dr. Hajwan Hussain, for your excellent talk. There is always one more thing to learn, but today we received many from you. So before we continue to the next speech, I would like to ask if everyone in the room, can see the video clearly, because in my place it's a little bit blur the video itself?
Yeah, same with me. I guess I was about to ask, but I thought it's my connection.
Okay,
But
okay.
I just realized that there's a, question asked here.
Okay.
But I do put the link. I have published it on the YouTube, so you can actually watch it later on, probably to understand better.
Okay, thank you. Thank you very much, Doctor. So in short, actually, Dr. Haswan Hussain give a talk about the development of wood adhesive from oil palm wood by using the lignin, right? Am I right, Professor?
Yes.
Yes. Okay. So that's the summary of his talk. So again, we would like to invite you, the participants, to give a round of applause to our invited speaker, Associate Professor Dr. Muhammad Haswan Hussain. You may use the clapping hand icon on your screen. If you have any question for our invited speaker, please hold on as we will listen to our second speech. And during the question and answer session, you may deliver your questions. And before we continue to our next speech, I would like to again remind everyone of these things. First, we will have a question and answer session at the end of this session, and the time is about 10 to 15 minutes. So to our invited speakers, please also have your presentation file ready in order to answer some questions from your slide. For the participants who would like to ask a question, please use the raise hand function at participants menu on your Zoom, or you may write down your questions on the chat room during the presentation session. And lastly, we will have photo sessions at the end of this session, so please keep in with us until the end. Now we will continue to listen to the second speech delivered by our second invited speaker, Dr. Hua Juan. I will firstly read her short bio to introduce Dr. Hua Juan to all of us. Our IT team, could you display Dr. Hua Juan short bio? Okay, let's wait a minute. The short bio, please. The short bio. Okay, thank you. So our next invited speaker, Dr. Hua Yuan, or Dr. Xuan, was born and raised in Xinjiang, China. She earned her bachelor degree from Zhengzhou University and doctoral degree in polymer chemistry and physics from Fudan University in 2012. She started working as a researcher focusing on wood science and technology in Research Institute of Wood and Industry, or usually abbreviated as CRIWI, Chinese Academy of Forestry, since 2012. At present, she is the Associate Professor, Deputy Director of Department of Wood Anatomy and Utilization in CRIWI, and the Deputy of International Union of Forest Research Organizations, 5.600, Properties and Utilization of Plantation Wood. She has published 50 literatures, 3 books, and 3 standards. As a mother of 2 beautiful children who make efforts to achieve the work-life balance, she is pleased by exploring both the mysteries of tree life and the meaning of family. So that is the short bio from our next invited speakers. Now, Dr. Juan, we also have your presentation file with us, but if you would like to control your own PPT, you are welcome to do so. Okay. So would you like to control your own PPT, presentation file? We couldn't hear your voice. I'm sorry. Okay.
Voice.
Okay, yeah. So we already, we hear you.
Okay. Can you hear my presentation?
Okay, so.
Okay. Thanks very much for very nice introductions, and thanks again. And it's our pleasure to have this opportunity to attend the second International Conference of Lignocellulose. On behalf of my colleagues, I will show our recent work. I'm Guo Juan from Research Institute of Wood Industry, Chinese Academy of Forestry. Today, the presentation topic is From the Forestry to the Sustainable Wood Products, Highlights and the Perspective of Wood Science in Chinese Academy of Forestry. The presentation, there are three parts. First, a brief introduction of CAF and CRIVI. Next, I will show the highlights of wood science progress in our CAF. The last, I will give some perspectives of wood science progress. First, let me briefly introduce the CAF and CRIVI. Chinese Academy of Forestry is founded in 1958. It is a comprehensive multidiscipline and public research institution engaged in forest research. It is directly subordinate to the National Forestry and Grassland Administration. There are 18 institutes and research centers, including the Research Institute of Forestry, Research Institute of Subtropical Forestry, Research Institute of Forestry Policy and Information, Institute of Wood Industry, Institute of Chemical Industry of Forest Products, and so on. And also there are 27 branch academies. They are distributed in 24 provinces, regions, and municipalities in China. Our institute, Research Institute of Wood Industry, it is founded in 1957. We are engaged in the research of wood science and technology. There are 11 departments, 3 centers, 1 wood collection, and 1 king laboratory. There are 4 departments mainly working for the research of wood structure and properties, and we have 5 departments focused on the wood utilization. Besides, we also have 1 department works for the innovating the wood processing technologies, and we also have 1 department working for the international and national standards. The second, highlights of the wood science progress in CAF. Wood collections is one of the most important fundamental research in CAF. We collect wood samples from the trunk and also branches of wood because they contain the different material information including the mechanical trails, chemical trails, wood properties, and genetic trails. So we can use the wood collections to solve a lot of problems in different areas, such as the carbon stocks, archaeological and wood technology, and so on. After collecting samples in the past over 19 years, the wood collection of CAF have become the largest one in China. At present, there are about 36,000 wood species from 9,638 species. Because CAF also participates in the archaeological wooden artifacts, so we also have 10,479 archaeological specimens. Besides, we also have about 36,000 microscopy slides, as well as about 6,000 herbarium specimens. Until now, we have exchanged wood samples with over 70 countries and regions. In 2020, in order to promote the fundamental research and development of wood collections, our institute CRIVI led the National Information Alliance for Wood Collections in China. There are 42 fundamental members units from the research institutes, universities, quality inspection institutions, customers, and enterprise in China. In order to conduct the wood science and technology driven by big data-driven processes, the important commercial wood database was also established in CAF. At present, the database covers 208,638 data items, come from the 2077 wood species. The data are coming from the wood anatomy trails, wood microscopy images, DNA barcodes, wood property information, and wood processing utilization information. For a short summary, the fundamental research in wood science in CAF, we are mainly focused on understanding the hierarchical structure and property in wood. For example, we monitor the microscopic changes of vessels, tree sheets, fibers, recells during the cell formation and differentiation. And also we promote the cell wall ultrastructures and peace in woods. Besides, we also focus on the chemical structure and the spatial distribution of cell wall components in cells, as well as the aggregation structure of microfibers. Besides, we also study the different cells in response to drying and also monitor the wood chemical properties at the large scale. Due to these works in the past 20 years, there are many books have been published by our institutes. On basis of fundamental research in wood science, our institute also conduct applied research in wood science, including the plywood, particle board, panels, adhesives, electric heating plywood, wood scramble, bump scramble, heat steam compressed wood, cross-laminated timber, wood composition materials, and also processing technologies for doors, furniture, decorated panels. Besides, we also conduct wood identification and also archaeological wood research. In the following, I will give some highlights to some applied research in our institute. The first one, wood scramble and bump scramble. They are made from the crushed fibers through the splitting, defibering, dipping, drying, processing, assembling, hot cleaning, and hot pressing technologies. Because of the excellent mechanical properties and decorations, they are widely applied in outdoors furnitures, such as the buildings, the house buildings, wooden buildings, and the wind turbine blinds. For detailed information, you can find it in this review and other related published literatures. Next, heat, steam, compression wood. Heat treatment, thermal hygromechanical treatment can significantly improve wood properties, including mechanical properties and size dimensional abilities. So in the past few years, we have conducted research on this area. We studied the changes of morphology structures, cell wall components, microfiber structures, and pores in wood in response to the heat, steam, and compression. We reviewed the influence of compression ratio, heat temperature, steam temperature on the properties of wood. Professor Huang invented this treatment. The name is sandwich compression wood treatment. It can significantly improve the wood properties at the minimum compression ratio as needed. For this part, more information can be found in these papers. CLT, cross-laminated timber. CLT In our institute, we also have some groups are focusing on this area. CLT is a very good large area engineering wood product. It has a good potential in the high-rise wooden structures and can be used in different areas in the building, the walling, the floors, and walls. In the past few years, our colleagues are working on the study the influence of different factors, the wood species, the processing factors on the performance of a CLT. They also to monitor the chemical properties and the dimensional stabilities of CLT under the loading at large scale. Besides, we also have some interest in fabricate the wood bump functional materials. This publication was published this year. We have fabricated the financial materials from the wood and bump, including the energy device, color converting transparent wood, wood-based electric skin, high-performance functional treated wood, flexible pressure center, and also wood spawns. If you need some more information, you can search these papers. Wood identification. This is mainly worked by our group. In CAF, you can get 5 solutions for wood identification. The first is a method of wood anatomy. By this way, if we want to know the wood species, we should carefully observe the microstructure on microstructures and correctly distinguish the anatomical structures. Professor Jiang participates in making the IW list of microscopy features for softwood identification. At present, we are promoting the standardization of wood identification by this method. At present, we have reviewed anatomical characteristics of 85% of commercial wood in China. The next way is DAN barcoding method. It is a very good choice to get the wood identification on the species level. We innovate the protocol of DNA extractions from wood. At present, the DNA yield and extraction efficiency have been increased by 200% and 58% respectively. We also promote a multi-level strategy of universal, specific, and combination of DNA barcodes. So the accuracy of wood identification at the species level can be increased by 54%. Now we have established the wood DNA barcodes database. The data is from the 41 endangered and precious tree species. The next method is computer vision via machine learning approaches. This method is a very fast developed method. In 2020, we self-developed wood image acquisition device. The name is iWood. This device have a high resolution and a big field of view. We also established the anatomical trails image database consisting of 41 endangered precise tree species, 6,680 wood vultures specimens. The images, there are 8,505 high-resolution images. Due to this database and also the device, and applied the 4 kinds of deep learning models, we can get the accuracy of wood identification at the species level approach to 99.63%. This year, we have get the iWood device and also iWood softwares for mobile phone. It has been applied successfully this year. Next is the chemical fingerprint. We can get the wood information from the wood by the dirt mass and also head space GC mass. We can also get the wood information from the wood extractives by GC mass. Combined with the chemical matrix, we can easily distinguish species. For example, these two species. The last method is we proposed this year. Generally, if we use the wood anatomical structures, we can't get the wood identification on the species level. This year, we realized that if we innovate this protocol to using quantitative wood anatomy, we coupled with machine learning processes, we can get the wood identification on the species level. This protocol has been successfully used to distinguish the 14 CITES list species with 15 of their look-alike species. For example, we use this naive Bayer classifier and 5 anatomical trails: vessel diameter, vessel frequency, ring width, ring height, and ring frequencies. We can distinguish these species from their look-alike species. The accuracy can be approached to 95.83%. Besides the archaeological wood, a human use wood to fabricate the buildings, bridges, artifacts for many years. As a very important cultural relics, these kinds of materials can provide the unique knowledge about the science, technology, and historical culture of their time. But because of the silver deterioration happened, they are far inferior to the non-decayed wood. So the conversation faced huge challenges. Archaeologists have little experience with this kind of material, archaeological wood. So as wood researchers, we have a responsibility to innovate some methods. In the past few years, we innovated the characterization of archaeological wood and reviewed the hierarchical structure and property of archaeological wood. For example, the deterioration state evaluation. Commonly, the evaluation is mainly achieved by studying the anatomical structure, wood properties, physical properties, and mechanical properties. From the book's guidelines, the mainly methods are destructives and macro-destructive methods. So what about the non-destructive sampling methods? In the past 5 years, we focused on this part and promote some methods to evaluate non-destructively. For example, we utilize the digital recording system and use the anatomy analysis by computer-assisted image analysis technologies. We can get the evaluation easily. Besides, we also use the chemical information by near IR and data mass spectrum. Combined with the chemical matrix, we can establish different models to evaluate the deterioration state of wooden artifacts by non-destructively. Using the protocols developed by us, we have successfully evaluated several archaeological wooden specimens. This is just a sample. They are sheep, Chinese sheep wrecks from different periods. The last part, prospective wood science progress in CAF. We realized that the big data-driven process can promote the wood science and technology. So expected that in the few years, in the future, we can promote the data-driven wood science, develop wood informatics, and also review the cross-skill structure, property, and the performance of wood system. Besides, we should strengthen the innovation chain to review the role of wood information on different areas, different fields. This is our research group, and thanks very much for your attending. If you have any suggestions or information needs, you can contact with me. Thanks very much.
Thank you, Dr. Huan, for your excellent talk. We learn a lot from your presentation today about your institutions and also about the research progress being there. Hopefully one day each one of us here in this room will be able to visit your institutions in the future. So ladies and gentlemen, let's give a round of applause to our invited speaker, Dr. Huan. You may use the clapping hand icon on your screen. And now we will have our question and answer session for about 10 to 15 minutes. For the participants who would like to ask a question, you can use the raise hand function at participants on your Zoom and turn your camera on. Or you can also write down your question in the chat room. I've read the chat room. I've seen the chat room and I have read some questions first. So while we are waiting for participants who would like to deliver the question directly, I will read the questions from the chat room first. So we have one question. Wait a minute. Okay, so we have one question for Professor Hazwan. This is from Ms. Nisa Nurfajrin. The question is, Professor Hazwan, thank you for impressive presentations. Lignin is very interesting to study, but the complex structure of lignin make it difficult to react with other substances. In your study, you did organosolve lignin to create high concentration of phenolic and methoxyl. But did your group ever conduct depolymerization lignin by using catalysts? Oh, we also have another question for Professor Hazwan Hussain from Professor Wahyu Dwianto. I will read the questions. Are you working or having a research collaboration with Professor Philip Gerardin from Lorraine University to develop lignin as a substitute for wood adhesives? And for Dr. Huo Yuan, you also have questions from Professor Wahyu Dwianto, who is investigating intensively on heat or steam or compressed wood in your institutions at Research Institute of Wood Industry, China's Academy of Forestry. To Professor Hazwan and Dr. Huo Yuan, please, you can answer their questions. Thank you.
Okay, thank you. Thank you, the chair, for the question. So I refer to the first question by Ms. Nisa. Yes, obviously, when we talk about lignin, we know that this is actually a very much stable compound due to the structure and the challenge of forming the cross-linking or any sorts of other application will be challenging. So in our focus previously was we do some modulation. I mean, like we modify the structure of lignin by means of fractionation, or we can do some grafting or whatsoever. So I think with this kind of purpose, you can have like a more functionalities which would be useful for the cross-linking in terms of like wood adhesive application. But I think you are asking whether we have done some research on depolymerization of lignin using a catalyst. Obviously, the answer is yes. We did some depolymerization, I think, analysis or testing with lignin, because of we want to quantify the monomeric content of lignin, which I refer to the H, G, and S units. So we did several I think analysis using HPLC. In this case, we oxidize the lignin using a nitrobenzene, for example, and the lignin will be depolymerized, forming monomeric units, which later on we can actually quantify. So for us, previously we did this with the purpose that we want to understand again what will be the contribution of this HGS unit to the cross-linking properties of a wood adhesive. So we found out that as we actually quantify the H, G, and S units, let's say that you have more H and G units, this could give you more tendency for the cross-linking to happen. So apart from using nitrobenzene as the catalyst or the chemicals to depolymerize lignin, we also did other things using metals as a support, like copper-based catalyst, for example. But I think some of this depolymerization technique is not really favorable, because I think in the end of the day, the recovery of like copper or nitrobenzene after the reaction will be tricky, because this I think chemicals or compounds is very much toxic. So I think in other approach, they also did another process, which not using a catalyst, but a so-called pyrolysis assisted methods, using a furnace, which later on connected with GC, gas chromatography mass spec. So I think maybe some of you well known of these methods. It's like a pyrolysis GC mass technique, where it also can separates the monomeric unit, and we can do the quantification. So I hope that answers the question. I think I'm moving on to the next question by Pak Wahyu. I think the collaboration with LERMAP from our group is quite strong. But in terms of the wood adhesive collaboration, I work a lot with Nicolas Bros rather than Philippe Girardin. I think my recent visit to France last May and June, I met Professor Girardin, and I think their work recently is more focused on wood preservation rather than adhesive. So I guess maybe one of BRIN researchers, Prabhu, if I'm not mistaken, is currently doing his PhD under the supervision of Philippe Girardin. So I think we still have a connection between us and Philippe Girardin, but I think their work is more on wood preservation rather than the adhesive. So adhesive, we are working with the other groups, but still in the same lab institutes.
Thank you very much.
Thank you, Pak Wahyu.
Thank you. Dr. Hyuan, please, you can answer the question.
Okay, thank you very much for the questions, and it can give me some minutes to introduction these areas more detailedly. In our institute, if you want to contact the fundamental research about the heat steam compression wood, you can contact with me. I did some works on this part. I mainly study the changes of wood compositions and the hierarchical structures and properties in response to the treatment process. And if you want to get the technologies, processing technologies about this treatment, you can contact with the Department of Wood Physics. Professor Huang, Professor Liu, they are mainly focused on this part. They are fabricate the larger device to make the treatment, and their products have been widely used in floors.
Thank you.
Thank you, Dr. Huan. Oh, we have another question. Okay, so this is from Dr. Adik Bahanawan to Professor Hajwan. His question is, does organosolved lignin have any differences from kraft lignin and lignin soda in terms of molecular weight? What is the best performance for adhesives from low molecular weight or higher molecular weight lignin raw material? He is interested in transparent wood research. Are there any latest developments of this topic at your institutions? Okay, so he has two questions for you, Professor Hajwan. Please, you can answer the question. Thank you.
Okay, thank you again, Ibu Karnita. Okay, but for this kind of question, this is a very good question. We actually did several pulping process in order to understand the structure of lignin, because we have to understand that whenever we isolate lignins from different process, the types of lignin and the properties will be different. Obviously, this is also related with the molecular weight as well. And when I did the presentation, probably you can capture that using a kraft lignin process, you will get more yield of lignin, but in the end of the day, the molecular weight will be larger because the condensation process happens quite rapid, and it happens that the structure of lignin become condensed. Rather than when you actually use an organosolved process, the yield is slightly low, but the properties in terms of like solubility and whatsoever is better. So we did check in terms of like the content of aromatic, phenolic and whatsoever, and we found out that it has a clear difference between these two different process. In our research, actually, we have found out that the one that having slightly lower molecular weight will give a better properties of adhesive. Why? Because of when you have a lower molecular weights of lignin, it means that you have a lower fragments of lignin, which eventually can give more opportunity for cross-linking to happen. And bear in mind that when we want to produce a wood adhesive, a cross-linking rate formation is considered important. And whenever the cross-linking, the chances of cross-linking to happen is higher, then it means that you will get a very good adhesive in terms of their tensile properties, internal bonding and whatsoever. So we did test with I think a more condensed structure of lignin, like for example kraft, soda, acetonosolv and whatsoever, and if we found that it gave a different properties. And obviously the cross-linking process is not as easy as when we use organosolved lignin. Again, as I said, because of lignin structure or fragments of from organosolved process is I think slightly smaller, then you can have more sites for cross-linking to happen, rather than if you have a complex structure from kraft or soda lignin, which eventually give a lower chance for cross-linking to happen, and this will affect to the properties of wood adhesive in the end. So I think I've done with the question. I guess the second question or the later question is related to Dr. Juan, I guess.
Yes, thank you. It's my fault. Yeah. Okay, so the second question is actually for Dr. Hyuan. So Dr. Adik is interested in the research on transparent wood. If you can give short explanation about the development in your institution. Thank you.
Okay, thanks very much. About the transparent wood in our institute, I think we have these skills to fabricating the transparent wood around 3 or 4 years ago. At present, we mainly focus on fabricating functional transparent wood, such as if we filled more content doors in the transparent wood, we can get the color converting material. If we add others, we can get like a skin device, skin sensors, and also other different kinds of electric sensors. So the latest development in about the transparent wood, this is our latest development about the transparent wood. Thank you.
Thank you, Dr. Hyuan. So everyone, as we will close to the end of the session, so we will, we run out of time actually. So we will close our session for today. Not for today, for this session, we will close the session here. And then to everyone who still have questions, for Professor Hassan Hussein or Dr. Hyuan, you may send your questions, through their email contacts. I think they would love to receive your email asking them questions about their work. Okay, so before we close our sessions, let's take a picture together with our invited speaker. Okay, so before we get our lunch break, so to everyone in the room, please turn your camera on. I've seen a lot of names without the camera, so I wonder where they are. So, okay, please turn your camera on, and then next I will ask our IT team to guide us for the photo sessions. But Dia, okay, you may give your guidance. My guidance. Okay, thank you.
Okay, thank you. We have 2 pages here, so please for the first page, I will screen capture first. So please keep your smile and see your beautiful and handsome face. Okay, I will count to 3. 1, 2, 3. All right, wait a minute. Thank you. For the next page, smile. 1, 2, 3. Okay, thank you very much.
Okay, so that is the end of our first sessions. Again, please give applause for our both speakers. Thank you, Dr. Associate Professor Dr. Hassan Hussein and then Dr. Hyuan for your talk. And thank you, everyone. See you again, especially the presenter, very soon in our next parallel presentation sessions after lunch break.
Thank you.
Bye.
Thank you. Goodbye.
Bye. Thank you. Bye-bye.
Thank you very much, Professor Hassan and Dr.
See you
Hyuan.
again very soon. You are also invited to attend the next paper presentation session to Professor Hussein and Dr. Hyuan if you would like to. Okay, so we will have 3 paper presentation sessions until 4 p.m. today. So you are also welcome to attend those sessions. Okay. Thank you. See you again soon. Bye.
So for the participants, continue at 12:30 as a schedule. Thank you.
Assalamualaikum.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome back to our parallel session. Can everyone hear my voice yet? I hope everyone can hear my voice.
Clear.
Yes, Dr. Kanita, we can hear your voice.
Okay, thank you.
Clear.
Okay, so now we will start our first paper presentation sessions. For the first paper presentations, we will have 6 presentations from Mr. Darussalam from Research Center for Biomass and Bioproduct, 2, Mr. Epia Triharpi Ginting from Universitas Sumatera Utara, 3, presentation from Mr. Ridho Maimangulo from Universitas Sumatera Utara, 4, presentation from Mr. Ahmad Supriyadi from Research Center for Biomass and Bioproduct, 5, a presentation from Mr. Wahyu Diwianto from Research Center for Biomass and Bioproduct, and 6, a presentation from Mrs. Yalin Adalina from Research Center for Biomass and Bioproduct. Before we proceed to the first presentations, I would like to check, are all the presenters already here? Please, to the 6 presenters I have mentioned before, could you give your voice here? Are you already here? Okay.
Yes.
Okay, thank you. So, firstly, I would like to again to remind you of some things, of several things. First, to our presenters, please turn your camera on throughout the session during the video, the presentation video, and then also through the question and answer sessions. We will have the question and answer session for about 10 minutes at the end of the session. So please have your presentation file ready in order to answer some questions from your slide. And for the participants who would like to ask a question, you can use the raise hand function at participants menu on your Zoom, or you may write down your questions on the chat room during the other presentation sessions. We will have a photo session at the end of our very last session in the third session. So for all presenters, after the session, after you finish your session today, your first session, you are allowed, to go and back to the other presentation room, but please come back again to this room before 4 p.m. Okay, so, and then also, this is, I think in the opening ceremony, everyone must heard about the award for best presenters. And we also are given freedom to add another criteria to that for that best presenter. So for the presenter who give questions to other presentation, we'll give additional point from us. So please everyone be active in the discussion. Okay, that's all. So we start the presentations. For the first presentation, we will watch a video prepared by Professor Research Darussalam. Professor Research Darussalam is the professor from Research Center for Biomass and Bioproduct. His video today will talk about usage comparison between reverse conventional and ladder type undercuts in natural forests at 2 logging companies in Central Kalimantan, Indonesia. To our IT team, you can play presentation video from Professor Darussalam. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Master Chairman. Ladies and gentlemen, today we would like to discuss about usage comparison between reverse conventional and ladder type undercut in natural forest at 2 logging companies in Central Kalimantan, Indonesia. Written by me, Sunarno, Sona Suwartana, Yuniawati, Sarah Andini, and Mutia Herniningrum. The usual trialing which commonly conducted using the conventional system still leave behind the pellet areas with substantial amount of waste wood. There are several various filing techniques to increase harvest efficiency, among others through the implementation of filing undercut form or manners such as reverse conventional and ladder shape type. Filing undercut that implement Humboldt type manner allow the tree filing to proceed relatively faster and therefore can effectively reduce the kicking back effect of those felled trees. The main purpose of conducting this investigation was to acquire reliable data and information about appropriate tree felling techniques at logging companies with expected low negative or minimum destructive impacts on the residual stand, and the results are forthcoming. Method. The research was conducted in 3 filing plots which was managed by 1 logging companies and licensed natural forest concentrate area of PT Barito Putra and PT Dasa Intika in Central Kalimantan, Indonesia in June 2013. The materials used for this investigation comprise mainly the tree stand which had already existed for the harvest planning, wood pine, and plastic ropes. The equipment was exclusively the field equipment that covered meter measuring device, time measuring device, or stopwatch, knives, and gasoline-powered chainsaw of steel 070. The gathering of data and information was acquired from the primary and secondary source. The primary data information covered working time, working or tree felling productivity, and damage residual tree stand at the felling area that implemented two techniques that comprise consecutively Humboldt undercut of figure 1 and ladder shape undercut manner of figure 2. This is figure 1 Humboldt undercut, and this is figure 2 ladder shape undercut. Data processing, log volume V equal to 1 divided by 4 V produced by D divided by 100 and square and productivity by L, where V equal to log volume cubic meter, D equal to log diameter or centimeter, 100 equal to conversion between centimeter and meter, and L equal to long length or meter. Felling efficiency E equal to VW divided VI produced by 100%, where E equal to felling efficiency or percent, VW equal to volume of timber wood or ready to be utilized or cubic meter, PE equal to volume of timber which was expectedly usable or cubic meter. Residual stand damage DRS equal to NRSD divided by PNRS productivity by 100%, where DRS equal to damage at the residual stand percent and DRS number of damage residual stand caused by the felling work or trees, PNRS equal to potential number of overall intake residual tree stand or trees as if the felling work did not inflict any damage at all on such stand. Result, felling productivity in the PT Barito Putra, the average is 21.91 cubic meter per hour, and in ladder shape productivity, the average is 14.62 cubic meter per hour. In PT Dasa Intiga, the average humboldt type productivity is 28.17, and the average of leadership productivity and leadership is 21.04%. The filing efficiency in the PT Barito Putra, the humboldt type efficiency is 90.18%, and the leadership efficiency average is 89.34%. And PT Dasa Intiga, the average humboldt type efficiency is 90.73%, and the leadership efficiency is 88.79%. Now, residual stand damage, the residual stand damage in humboldt type, the average is 9.95%, and leadership, the average is 7.38%. And in PT Dasa Intiga humboldt type, the average is 5.41%, and leadership average is 8.15%. The conclusion: productivity of the tree felling performed at the area and the work permit for processing of wood forest product from natural forest in central Kalimantan that implemented the humboldt type undercut manner were higher, 21.19 and 28.17 cubic meter per hour in average, that the implemented in leadership undercut manner of 14.82 and 21.05 meter cubic per hour in average. Tree felling efficiency with humboldt type undercut manner was also higher, 93.81 and 94.73% in average compared to the with leadership undercut manner, 89.34 and 88.79 in average. The damage of residual stand due to the implementation of humboldt type felling undercut manner was lower, 4.41 and 6.65% than those that implemented the leadership felling undercut manner, 7.38 and 8.15%. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Abdul Salam. Now our next video will be from Mr. Erpia Triharti Ginting. Mr. Ginting is a student from Universitas Sumatera Utara majoring in forestry. Mr. Ginting will talk about effect of planting distance from the beach on red mangrove plants Rhizopora apiculata on the coastal coast of Pulau 9 village Pangkalan Susu, Langkat Regency. To our IT team, please play Mr. Ginting's video. Thank you.
Hello everyone, thank you for the opportunity and time given to present my journal with the title Effect of Planting Distance from the Beach on Red Mangrove Plants Rhizopora apiculata on the coastal coast of Pulau 9 village Pangkalan Susu, Langkat Regency. My name is Erpia Triharti Ginting. I am from Faculty of Forestry, University of North Sumatra, Medan, Indonesia. Preliminary, Indonesia is a maritime country with the fourth longest coastline in the world, with mangrove forest reaching a percentage 23 of the total mangrove ecosystem in the world. Mangrove forest in ecosystem interradial area where there is a strong interaction between marine, river, breakage, and terrestrial water. According to Konom et al., 2019 mangrove forests have an important role for living things. Their main function of mangrove, namely 1. The physical function are flood control, with and wave barrier and prevention of seawater intrusion on. 2. The economy function and the produce wood holding material ends and waters. Red mangrove is one of the mangrove special found on the island of Sembilan. The special nomination and grows along the coast, but due to the distension and direction of landing that is not stable, the distribution of the species is uneven. In order for the species to grow well enough and even distribution, this research was researched out. Destination: knowing the effect of spacing on the red mangrove Rhizophora apiculata. Benefit: as information material of the public about the red mangrove Rhizophora apiculata. Research methods: time and place: mangrove forest in Pulau Sembilan Village, Pangkalan Susu District, Langkat Regency, as well as that forest cultivation laboratory, Faculty of Forestry, University of Sumatra from October 2020 to December 2020. Tools and material: tools, analytic balance, ruler, stick, caliper, meter, stationary, oven, camera, laptop, SPSS application, material, Rhizophora apiculata seeds. Research procedure: seedling of Rhizophora apiculata used the study amounted to 13 seedling using 5 treatment and 6 rep session. Seedling were planted at distance of 1 × 1 meters, 43 until 47 meters from the source wood. Data was collected after planting with a span of once every 15 days. Every dairy is carried or immediately within 14 days after planting. If there are plants that using a spare seed that have been prepared. To control pests and diseases is also done so that the seeds are planted properly. Observation and data collection were carried out every 2 weeks. While their parameter observed fit well: seedling height, seedling diameter, number of leaves, temperature, plant wet height, plant dry height, leaf area. Harvesting was carried out on the 6th observation and was carried out manually. Leaf area index analysis: leaf area index is measured by comparison with leaf surface area, only one surface. Leaf area index analysis determined using image application. Data analysis: the data were analyzed by means of analysis of variance, and if there were signification, their result P is less than 0.05. Between treatment, education, multiplication, rank test was carried out an error rate of 5%. Result in this question: seedling height, centimeter. The results of the analysis of variance in seedling height showed that the value of 6 greater than 0.05, that is equal to 0.377, where H0 is accepted and H1 is rejected. In table 1, it can be seen that treatment P2 planting distance from the beach 44 meters at the heights had that value in Rhizophora apiculata seedling compared to other treatments with a value of 260.70 cm with an average of 36.12 cm and treatment P4 planting distance from the beach 47 meters and the low wedge growth of seedling height with a total of 173.80 cm and the average of 28.97 cm. Table 1, average height of Rhizophora apiculata seedling for 6 observation. Seedling diameters, millimeters. The results of the analysis of seedling diameter variance show that value of signification greater than 0.05, which is 0.271, where H0 is accepted and H1 is rejected. Table 2 shows that the diameter of Rhizophora apiculata seedlings experienced an increase in diameter. The highest average diameter increase was in the P1 treatment of 1.18 cm and the lowest diameter increase was in the P2 treatment of 1.00 cm. Table 2, average diameter of Rhizophora apiculata seedling for 6 observation. Number of leaves, strands. The results of the analysis of variance in the number of leaves showed that value of signification greater than 0.05, which is 0.247, where H0 is accepted and H1 is rejected. Table 3 shows that the number of leaves of Rhizophora apiculata seedlings increased. The highest increase in the number of leaves was in tremor P1 as much 6.0 and the lowest increase in the number of leaves in treatment P4 as much 4.7. Table 3, offering left number of reservoir apiculata settling for 6 observation. Plain wet white grams. The results of analysis of variance obtained the value of signification greater than 0.05. The signification value of the wet white of leaves, roots, and stems respectively is 0.488, 0.514, 0.548. So H0 is accepted and H1 is rejected. Table 4 shows that the height offering left wet white of reservoir apiculata seedlings was the P3 treatment of 11.50 grams and the loss offering left wet white was in the P1 treatment of 6.89 grams. Table 4 offering left wet white of reservoir apiculata seedlings for 6 observation. Plain wet white grams. Table 5 show that the heights offering root wet white of reservoir apiculata seedlings was in the P3 treatment of 60.27 grams and lowest offering root wet white was in the P5 treatment of 12.26 grams. Table 5 offering root wet white of reservoir apiculata seedlings for 6 observation. Table 6 show that the heights offering steam wet day of reservoir apiculata seedlings was in the treatment P1 of 27.62 grams and the lowest offering wet white of stems was in treatment P2 of 22.36 grams. Table 6 offering stems wet white of reservoir apiculata seeds for 6 observation. Plain dry white grams. The results of analysis of variance obtained the value of signification greater than 0.05. The signification value of dry white of leaves, roots, and stems respectively was 0.19, 0.33, 0.447. So H0 was accepted and H1 was rejected. Table 7 show that the heights offering left dry white of reservoir apiculata seedlings was in the P3 treatment of 3.21 grams and the lowest offering left dry white was in the P4 treatment of 2.06 grams. Table 7 offering left dry white of reservoir apiculata seedlings for 6 observation. Table 8 shows that the heights offering steam dry white of reservoir apiculata seedlings was in the treatment P4 of 6.32 grams and the lowest offering steam dry white was in the treatment P2 of 4.96 grams. Table 8 offering steam dry white of reservoir apiculata seedlings for 6 observation. Plain dry white grams. Table 9 shows that the heights offering root dry white of reservoir apiculata seedlings was in treatment P3 of 7.91 grams and the lowest offering the weight of stems was in treatment P4 of 5.28 grams. Table 9 offering root dry white of reservoir apiculata seeds for 6 observation. Leaf area. The results of the analysis of leaf area variances of seedlings showed that the value of signification greater than 0.05, which is 0.377, where H0 is accepted and H1 is rejected. Table 10 shows that the heights offering leaf area of reservoir apiculata seedlings was in the treatment P2 of 28.67 cm and the lowest offering leaf area was in treatment P1 of 24.40 cm. Table 10 offering leaf area of reservoir apiculata seedling for 6 observation. Leaf area index analysis. The results of analysis of leaf area variance of seedling shows with the value of signification greater than 0.05, which is 0.598, where H0 is accepted and H1 is rejected. Table 5 shows that the P3 treatment planting at distance of 46 meters from the coastline at the highest leaf area index value of 60.82 and the lowest leaf area index value was at P1 treatment, planting at a distance of 44 meters from the shoreline with a value of 35.76. Table 11 analysis of leaf area index of reservoir apiculata. Plant growth rate. Based on the results that have been observation in the file, can be seen the offering value of its treatment of reservoir apiculata plants with 6 replication for 3 months of observation. Based on the data on the results of the growth rate of observed in reservoir apiculata given the treatment, the highest seedling height growth was in treatment P5, planting distance from the beach 47 meters, and the height gauge stem diameter parameter in Rhizopora apiculata seedlings was in treatment 44 planting distance from the beads 46 meters. The parameter of number of leaves with the heights averaging in the P2 treatment planting distance from this the beads 44 meters of 21 leaves for 3 months of observation. Table 12 grow rate of Rhizopora apiculata seedling for 3 months. Conclusion and recommendation. Conclusion: the result of study of plant spacing or Rhizopora apiculata mangrove seedling for 12 weeks showed that there was no significant effect. The percentage of plant growth was obtained at 100%. Based on the result of the study, it was shown that the most optimal spacing was in the P5 treatment 47 meter spacing, where for the average seedling height value of 37.7 cm 12 weeks, the average diameter value of 3.5 mm 12 weeks, and the average number of leaves was 14 strands 12 weeks. Recommendation: based on the result of the study, additional time is needed in observation because with a favorable time of 3 months, maximum growth, the results are not obtained. Thank you. Hello everyone. Thank you for the opportunity.
Our next video will be from Mr. Rido Melanjulo. He is also a student just graduated from the Universitas Sumatera Utara, majoring in Faculty of Forestry. His presentation today will talk about the effect of planting distance from the beach on mangrove plant on the coastal coast village Island 9, Pangkalan Susu District, Langkat Agency. So our IT team, you may play Mr. Rido Melanjulo video now. Thank you.
Thank you for your excellent opportunity, ladies and gentlemen. I will give you my research title, The Impact of Planting Distance on Mangrove Rhizopora apiculata, Coastal Beach Village Island 9, Subdistrict Pangkalan Susu, Langkat Agency. Introduction. Rhizopora apiculata, a species of the Rhizoporaceae family where the oil mangrove is one of the most important species in the mangrove forest ecosystem. Rhizopora apiculata is very hard as growing wood mangroves have breed roots, types of opposite lives, and up to 15 meter heights. Rhizopora apiculata has type 5 pores seed where the underside of the leaves is colored yellowish green. One of the characteristics of Rhizopora apiculata, what is different from other types of mangrove, is the leaves that are then to be smaller. The purpose of research: study and determine the effect of plant spacing which is useful for increasing growth for the mangrove ecosystem of the Rhizopora apiculata species. With this test, it's hoped that the growth of mangroves will increase and have an impact on the continuity of the mangrove ecosystem. The benefits of research: to provide information about the effect of distance that can increase growth in Rhizopora apiculata seedlings. Research methods. Phase. This research was conducted in the mangrove forest area of Island 9 village, Pangkalan Susu District, Langkat Agency, and the Forest Cultivation Laboratory. Time. This research activity was carried out in December to February 2021. Material. The material used is red mangrove, Rhizopora apiculata, seed whites have the same relative size as many as 30 seedlings. Tools. The tools used in the field research are markers, stationery, tape measure, caliper, oven, ruler, laptop, SPSS application, and camera. The procedure of research. Number 1. Determine the direction of the eye and measuring the distance from the shoreline. Number 2. Planting Rhizopora apiculata seeds. Number 3. Experiment design. Parameters of Rhizopora apiculata seedling research: seedling height, seedling diameter, number of leaves, temperature, plant with weight, in dry weight, leaf area index, plant growth rate analysis, data analysis. Result and discussion. Number 1. Seedling height. The average height of seedlings can be seen in the Table 1. Table 1 shows that in treatment 8.1, result in the height seedling height growth value compared to the treatment are with a value of 270.91 cm with an average of 44.23 cm. And treatment of 8.2 plant seeds, produces the lowest seedling size growth compared to other treatment is 233.44 cm with an average of 59.96. Number 2. Seedling diameter. The average diameter of Rhizopora apiculata for 12 weeks of observation can be seen in Table 2. From Table 2 showed that in treatment A1, result in the high seed diameter increased compared to white other treatments with a total of 73.13 with an average diameter of 12.35. And the treatment on the provision of A2 produces the lowest diameter increase value compared to the treatment orders, namely 56.76 with an average of 90.69. Next, number of leaves. The average leaf of Rhizopora apiculata for 12 weeks can be seen in the third table. The third table shows that the effect of spacing on the treatment A1 result in the added value of leaves compared with other treatments that is equal to 35.99 with an average of 5.73, and treatment with A3 result in the lowest increase in the number of leaves compared to other treatments with a total value of 29.33 with an average of 4.70. Next, weed weight plan. From the first figure, it can be seen that the weed weight of the root of Rhizopora apiculata seedlings, the height is in A3 of 35.28 gram. We witnessed the root of Rhizopora apiculata seedlings, the loss was in treatment A2 of 25.31 gram. Then the weed weight of the seedling stem, the height Rhizopora apiculata was in treatment A3 of 15.49 gram. While the weed weight at the root of the lost Rhizopora apiculata seedlings was in treatment A4 of 11.80 gram. And the weed weight on the leaves of the high Rhizopora apiculata seedlings was in treatment A3 of 7.11 gram. And the weed weight of the roots of Rhizopora apiculata, the loss was in treatment A4 of 5.10 gram. Dry weed plant. From the result of observation of the dry weed of the plant, which can be seen in the second picture, it was found that the highest dry weed of Rhizopora apiculata seedlings was in the treatment A3 was 18.27 gram, and the lowest dry weed was in treatment A4 of 13.37 gram. On dry weed, the highest number of plant on Rhizopora apiculata stems was in treatment A3 of 80.6 gram, while the dry weed of the plant on the stem of Rhizopora apiculata, the lowest was in treatment A4 of 5.82 gram. Then the dry weight of the leaves on the high Rhizopora apiculata plants was in treatment A1 was 2.76 gram, and the dry weight of the plant was on Rhizopora apiculata leaves, the lowest was in treatment A4 of 2.17 gram. Next, leaf area. The average leaf area of Rhizopora apiculata seeds for 12 weeks. Leaf area in treatment A1 result in the height leaf area value from the treatment other 334.60 centimeters with an average of 62.447 centimeters, and treatment on A4 result in the lowest leaf area value of other treatments that is equal to 118.83 centimeters with an average of 18.83 centimeters. The result of the growth of the average leaf area of seedlings can be seen in Table 4. Plant growth rate. The average growth rate of seeds Rhizopora apiculata. Data on plant growth rate can be seen in Table 5. Based on the result of the growth rate observed in the given Rhizopora apiculata, the height increase in seedling was in treatment A2, and on the parameters of the height stem diameter in seedlings Rhizopora apiculata was present in treatment A2, and on parameter of the number of leaves, it was found that the height average number of leaves was in treatment A5 of 21 leaves for 12 weeks observation. Conclusion. The result of the study in spacing in different mangrove Rhizopora apiculata seed for 12 weeks observation were not found significant real influences. The percentage of plant growth is 100%. Based on the result of the study, the most ideal spacing is to be used in the process of planting or mangrove rehabilitation on Rhizopora apiculata seed in A1 treatment. Data on observations at the height measurement, diameter and number of leaves that the treatment of species can increase growth in Rhizopora apiculata seeds. However, from the result of the INOPAT test treatment of spacing in the Rhizopora apiculata, plant did not affect the high growth of the stem, diameter, and increase in the number of leaves of Rhizophora apiculata seeds during the 12-week study. Acknowledgement to the Research and Community Service Institute that has assisted in financing based on the non-PNDT contract of the University of North Sumatra in accordance with the letter of assessment for the implementation of community service implementation of the regular year monopartnership scheme source of non-PNDT funds USU G.A T 2021 number 184/UN 5.2.3.21/BPM/2021. Thank you.
Thank you to Mr. Ridho Mailan Gulo. Our next video will be from Mr. Ahmad Supriyadi. Mr. Ahmad Supriyadi is a principal researcher from Research Center for Biomass and Bioproduct. He is majoring in wood machining and woodworking science. Today, he will talk about the machining properties of nyerakat and resak woods from West Kalimantan. To our IT team, you may play Mr. Ahmad Supriyadi's video now. Thank you.
Good morning, ladies and gentlemen. In this occasion, I will forward the presentation of my paper in detail, Machining Properties of Nyerakat and Resak Woods Originated from West Kalimantan, by me, Ahmad Supriyadi. In my presentation, the materials will be divided: introduction and background, materials and methods, research and discussion, conclusion and suggestion. Introduction and backgrounds. The ability to produce wood, especially from natural forests in Indonesia, continues to decline, whereas there are 147 species that are categorized as lesser-known wood species that haven't been utilized. Those lesser-known wood species should be explored, especially about their basic properties. Knowledge about basic properties could direct the appropriate uses of particular wood species in order to obtain maximum efficiency in the utilization of those wood. Those basic properties regarded as essential are among machinist properties. Relevantly, this paper describes the testing research about machining properties of nyerakat and resak woods, defining the machining properties which were examined covered by planing, shaving, boring, churning, and sanding. Materials and methods. The main material for this research consisted of nyerakat and resak woods originated from West Kalimantan. The equipment which were used consisted of loop, sewing machines, planing tools, shaving tools, churning tools, sanding tools, and boring tools. Research on observing and testing of the wood machining properties was conducted at the wood sewing and woodworking laboratories of the Center for Forest Product Research and Development located in Bogor. In preparing wood sample, it used defect-free board with the size of 120 cm as length by 12.5 cm as width by 2.5 cm as thickness, as many as 20 boards for each wood species. Further, those defect-free boards were divided into several test specimens for the testing of wood machining properties. The testing was performed by principal examining the wood defects caused by wood machining operation. The specimen size and procedures for testing refer to the modified standard of ESTM D-1666-SIG4. Research and discussion. kinds of wood defect that could occur due to its machining, total defect values, total defect-free values, and then wood machining class are presented in tables 3 until 7 as follows. Planning. You all can see that for Nyerakat woods, kind of defects resulting from the planning action on wood were dominantly tone grains as much as 11%, while for rusak woods, rice grain were the dominant as much as 11.25%. Both species with regard to machining qualities belong to class 2. Two wood species to be suitable as raw materials for woodworking products that necessitated good surface appearance such as table, chairs, and cupboard. Shaping. For Nyerakat woods, kind of defect resulting from the shaping action on woods were dominantly rice grain as much as 13%. Followed in decreasing order by fuzzy grain as much as 9.75%. Meanwhile, for rusak woods, fuzzy green were the dominant as much as 9%. Nyerakat woods belong as class 2, rusak wood belong as class 1. Both wood species could be recommended to be used as raw materials for molding products and wood carving products. Boring. For Nyerakat woods, kind of defect resulting from the boring action on wood were dominantly fuzzy green as much as 80.25%. For rusak woods, fuzzy green were also the dominant, namely 11%. Crushing defects and smoothness defects were not encountered on both species. Both species could evoke class 1. Both species could be combined or joined together with dowels or with gluing for the assembling laminated wood product. Churning. For Nyerakat woods, kind of defect resulting from the churning action on wood were dominantly surface roughness as much as 9%, followed by fuzzy grain as much as 6.75. For rusak woods, fuzzy grain were dominant, namely 11%, followed by surface roughness, namely 6.75%. Nyerakat wood was class 1 and for rusak wood was class 1 strip 2. Both wood species were suitable to be processed into particular wood products such as trellis, part of furniture, and other churning-related products. Sanding. You all can see the both species only fuzzy grain defect occur as much as consecutively 9.25% for Nyerakat and 11.75% for rusak. Further, best the defect-free value of both species were very good. Both species could favorably be assembled into wood products that necessitated favorable or attractive appearance such as table plan, wood panels, and wall lining. Conclusion and suggestions. Nyerakat would exhibit very good machining qualities with respect to boring, churning, and sanding, while the machining quality with respect to shaping and planing were good. Rusak wood afforded very good machining qualities with respect to saving, boring, and sanding, while the machining qualities with respect to planing were good. Further, for resac wood with respect to churning, the machining qualities were very good to good. Fuzzy grain defects occur at all 5 kinds of machining qualities. Different wood species affected significantly the planing and saving properties, but not significantly affected boring, churning, and sanding properties. Both species could be recommended to be processed into woodworking product expectedly with good until very good machining qualities. Thank you very much.
Thank you, Mr. Ahmad Supriyadi. And our next presentation video will be from Mr. Wahyu Diwianto. Mr. Wahyu Diwianto is our professor at Research Center for Biomass and Bioproduct. He is majoring in wood science and technology. This afternoon, he will talk about the formation pattern of compressed wood cell walls in radial direction and its effect on modulus of rupture values in different loading direction. To our IT team, you may please play Mr. Wahyu Diwianto's video now. Thank you.
Good afternoon, everyone. I would like to share our study on the formation pattern of compressed wood cell wall in radial direction and its effect on modulus of rupture values in different loading direction. The decline in the quantity of commercial timber from tropical natural forests has pushed effort to utilize fast-growing or lesser-used timber for various purposes. In an effort to utilize these woods for building material that experience structural load, it is absolutely necessary to increase their strength properties. This can be overcome by applying wood densification technique. Wood densification technique is a wood compression that aims to increase the surface hardness and strength of the wood. This technique can be applied to fast-growing wood species which generally have a low strength class through increasing their density. This figure shows our previous study on relationship between density of uncompressed and compressed wood with MOR. Each wood species has different density depending on its cell wall thickness. The density has significant correlation with strength of the wood. Typical stress strain curve shows a linear region below 0.05 compression strain, followed by a long continuing plateau through constant stress to around 0.5 compression strain, and lead into a final region of steeply rising stress regardless of wood species. However, each wood species has different deformation pattern when compressed in transverse direction. This figure shows stress strain curve of wood compression. In this study, the influence of loading direction in radial and tangential on the MOR value of agates and rubber woods which were compressed in radial direction were compared. The purpose of this study was to determine the strength of the wood when it received a load so that it could be seen how the wood was installed. This figure shows wood grain direction of Cryptomeria japonica or sugi wood. The softened hinoki with a specific gravity of 0.44 was used to observe the compressive deformation pattern. Wet wood sample with a cross-section of about 0.5 times 0.5 cm was smoothed in each surface by microtome. The wood sample was then compressed in the range of plateau region to 0.1, 0.2, and 0.3 strains in radial direction by artificial tool which especially designed for compressing a small sample manually. Compression strains were measured by dial gauge. These figures show microtome and manual compression tools. Cross-section deformation of cell wall in its compression strain from surface to the second groove ring were observed by laser electron microscope. The microscope was connected with analysis computer program, which was possible to rearrange the photographs by multiple image arrays. These figures show laser electron microscope. The sample used for bending tests were agates and rubber woods with specific gravity of 0.45 and 0.7 respectively. The sample were compressed in R direction after softening by using a hot press at 100 degrees centigrade for 4 hours with a final thickness of 1.8 centimeter or 35% compression level. Furthermore, the two groups of wood sample were made with a thickness of 0.5 centimeter in R and T direction. Bending test was carried out using the universal testing machine at room temperature. The MOR value of wood sample with loading in R and T direction were calculated based on the following formula. Hinoki wood was used to observe the compressive deformation pattern because the wood has a distinct border between late and early wood. Figure 6 shows Tochinoki wood, Figure 7 Kuri wood, and Figure 8 Hinoki wood. This figure shows cell wall deformation pattern of Hinoki compressed wood in radial direction. Collapse of honeycomb-like structure of cell wall were studied from upper part of early wood below the late wood at 0.5 compression strain. Collapse of the cell wall were more and more occur when the compression strain were extended to 0.2 and 0.3. This figure shows deformation of the second groove ring. The second groove ring has not deformed yet at 0.2 compression strain. Collapse of the second groove ring cell wall was studied when the compression strain was extended to 0.3. The collapse occurred mostly in the upper part of early wood below the late wood and the thin cell wall. This table shows the code of uncompressed and compressed agates and rubber woods with loading in radial and tangential direction. As a result of 35% compression level, the specific gravity of agates compressed wood increased from 0.45 to 0.6 and 0.7. The MOR value of agates uncompressed wood that were loaded from R direction were not different from the T direction, which were between 650 to 700 kilograms per centimeter square. Meanwhile, the MOR values of agates compressed wood which received loading from T direction were higher than those from R direction. Specific gravity of rubber compressed wood increased from 0.7 to 0.8 and 1. Similarly, the MOR values of rubber uncompressed wood were almost the same in R and T direction. However, the MOR values of rubber compressed wood which received loading from T direction were higher than those from R direction. Now we come to the conclusion. In the radial direction pressing process, the deformation of wood cell wall starting from a thin cell wall or early wood in case of hinoki. After exceeding the elastic limit, the cell wall collapsing from a hexagonal shape to being flat and arranged longitudinally toward the tangential direction. The flat shape of the cell walls caused the wood with loading from the T direction become stronger than the load from the R direction. Thank you very much for your attention.
Thank you, Mr. Wahyu Dwianto. Okay, everyone, please do not forget to register to fill in the presentation form for this session. Our next video will be from Mr. Cialin Adalina. Mr. Cialin Adalina is one of our senior researchers from Research Center for Biomass and Bioproduct. He is majoring in forest product, especially in nutraceutical products. Our talk for this afternoon will be about psychochemical characteristics of honey based on species of bees at Kapuk, Saiba Petandra plantation in Pati Regency. To our IT team, you may please play Mr. Cialin Adalina video now. Thank you.
Hello everyone, my name is Cialin Adalina. I want to share about physicochemical characteristic of honey based on species of bees at Kapuk plantation in Pati Regency. My others team are Nurul Wahyuni and Rosita Dewi from Research Center of Biomass and Bioproduct National Research and Innovation, or BRIN. The introduction. Indonesia is mega biodiversity country of honeybee. 7 species of bees are endemic from Indonesia. The species that cultivated by community around Kapuk plantation in Pati are Apis mellifera, Apis cerana, and Trigona leavisaps. Honey combustion are dependent on various factors. The species, source of nectar, climate, and topography. Physical and chemical quality of honey become standard in managing, storing, and processing honey. How is characteristic of Kapuk honey from Mellifera, Serena, and Trigona bee species? Aim of studies: determine physicochemical characteristic of honey from Mellifera, Serena, and Trigona bee species with source of nectar from Kapuk plain. Material and location. The materials are Kapuk honey, aqueous, ethanol, etc. Location: Kapuk honey sample at Telogobungu district, Pati Regency. The methods: honey sample. We use purposive sampling, study approach, quantitative with support qualitative approach. The methods: survey and interview, observe parameter, color, water content, pH, HMF, acidity, sugar content, and phytochemical. Data which obtained compared to Indonesian standard of honey quality, that is SNE 018664 2018. Result and discussion about these studies. The first is Kapuk honey quality from Apis mellifera, Apis cerana, and Trigona bee species. This table result analysis are color, water content, acidity, pH, HMF, reductive sugar content, and sucrose. These results explain Serena, mellifera, and trigona color. For Serena, 63 or light amber. For mellifera, 37 extra light amber, and trigona 87 light amber. And for the water content, Serena 2020, Apis mellifera 27.20, and trigona 28.60. For the water content, the trigona is higher than the others, and the acidity trigona is the higher than other. Acidity from trigona species is very acid than others. And for pH, Apis serena 3.92, Apis mellifera 4.05, and trigona 3.30. And HMF, the higher is Serena than others, and reductor sugar content is Serena is higher than others. The result of reductor content of Serena 69.94, and for the sucrose percentage, the trigona is higher than others. Trigona has sucrose percentage 3.18, and Apis mellifera 1.28, and Serena is 2.33. The color of honey result. Color of honey is important component for consumer. There is light amber, extra light amber, and amber. Honey color affected by source of nectar, which consumed by bees, the ratio of storing, and the processing of the honey. Color of kapuk honey is extra light amber to amber with intensity from 37 to 87 mm P4. Trigona honey is darker with higher intensity from Apis serena and Apis mellifera due to a lot of pollen mixed in the honey when extortioning and harvesting. Water content affect honey durability easily whether honey is fermented. Water content of honey from 3 different species is higher than the national standard Indonesia. That is 22% for Apis and 27.5% for bee without sting. The height of water content affected by weather, water content in the nectar, size of colony, humidity. When harvesting, not all honey are covered by wax. Hydroxymethyl fulfural or HMF. HMF as freshness and poorness indicator of honey. HMF level will rise as longer storing duration. HMF level from 3 species are 0.0558 to 0.1620 milligram per kilogram complies Indonesian national standard maximum 40 milligram per kilogram. That means the honey of the 3 bee species indicates that the honey freshly harvested and has not undergone a heating process or long storage. pH level is 3.30 to 4.05. Factor affected of honey is organic acid content, processing, and honey storing duration. Honey pH from trigona is lower from Apis serena and Apis mellifera because the difference of mineral and acid content in honey. The low of honey pH can affect honey stability to microorganism, flavor, and honey aroma. That means lower is affect to can stabilize the microorganism and into aroma. And the result of acidity is important criteria to determine the honey quality. Acidity level of kapuk honey from trigona is higher than kapuk honey from Apis serena and Apis mellifera, but still complies Indonesian National Standard 2018 standard. The high acidity of trigona honey is due to the content of free acids, minerals, and amino acids in honey. Factors that affect the acidity of honey are: the first is bee species, biophysical condition of honey harvesting site, the location, the weather, the climate, and honey maturity, and for the long storage. Harvesting is one of the affect the acidity of honey too. And the reduced sugar content and sucrose results. Sugar content in honey to determine the quality of honey and presence of adulteration in honey. The dominant types of sugar in honey are glucose and fructose, around 70 to 80%. There is a difference in the levels of reducing sugars of Randu honey or kapuk honey from the 3B species, but meet the standards of Indonesia national standard. The composition of honey sugar is influenced by the type of bee feed source honey. There is the pollen, sugar, biophysical, and climatic condition. And then the sucrose content of the honeycomb of the 3B species, Apis mellifera, Apis cerana, and Trigonum, meets the following criteria standard: maximum 5% of the 3B species. And then the level of sucrose in honey as an indicator in determining the authenticity of honey. Physicochemical analysis results or physicochemical analysis is a qualitative task for determining the presence of active compound contained in honey extract. Randu or kapuk honey from honeybee cerana contains the saponins and flavonoids, while the honeycomb from Apis mellifera and Trigona content of group saponin. Randu honey or kapuk honey from the three types of bee does not contain alkaloids, steroids, tannin, terpenoids, and quinone. The conclusion of these results are: the first, there are difference in the physicochemical characteristic of brown honey from bee species Apis cerana, Apis mellifera, and Trigona. All honey samples from the 3B species had hydromethyl furfural levels, acidity, reduction sugars, and sucrose level that meet the standards of Indonesian national standards. The pH value is low and acidic, has an extra light amber to light amber color for the three types of bee species. Randu honey or kapuk honey from Trigona and mellifera bees contain saponin as active compound, while the cerana bees contains only saponin and flavonoid. Randu honey from the bee type cerana has the best quality than mellifera and Trigona in terms of physicochemical characteristic of the honey and the content of secondary metabolites. Thank you, everyone.
Thank you, Mrs. Yalin Adalina, for the presentations. So those are all the videos we have for our first session. Now we will have our Q&A session for about 10 minutes. To all presenters, please turn your camera on and have your slides ready with you. Everyone who has questions, please use the right hand function in your Zoom screen, or you can write the question in the chat room now. Okay, so we have two participants raise their hand. First, we have Mrs. Where is it?
Listia,
Listia, yeah, Listia Mustika Dewi, yes, and then Mr. Imran Sofianto. Please, Mrs. Listia.
Yeah, thank you, Mbak Carlita. I have a question to Mas Ginting. Regarding your research is very important, like especially in the future, like we need this research to do like reforestation in mangrove area. But my question is just about the methods regarding the planting distance that you consider in your methods. Like I noticed that there are you use 5 different distances. Like what is actually the main consideration in determining the distance? Like did you consider about the seed types, like pasang surut, I allowed something like that? Like, yeah, just wondering about the consideration to determine the distance. And also another question to Mas Gulo. I think it's quite similar research. I noticed that the difference between Gulo and Ginting, if I'm not mistaken, is about the distance of the distance from bits to the seedlings. So just my question is there any difference in the seedling treatments? Like what is like how old is the seedlings that you use to your study? Like how old and how big is that? Like is there any minimum criteria to plant the seedlings to the coastal area, something like that? That's all. Thank you.
Thank you, Mrs. Celestia. And then our next question is from Mr. Imran. Please give your question.
Thank you. I have a question for code R604 for Mr. Ahmad Supriyadi. I have a suggestion. In my opinion, you should use the basic important information. So when people see your presentation, they can compare to other species, such as tick, right? From the presentation, in my mind, those two species are similar to tick for machining, because I think tick is class 1, yeah, for machining. Is it correct, Mr. Supriyadi? Thank you very much.
Okay, to Mr. Ginting, Mr. Gulo, and Mr. Ahmad Supriyadi.
Recording in progress.
Who is ready to answer the question?
Ditambahin di slide, dicantumin di slide. Terus kalau bisa dikasih perbandingan spesies lain, tingkat ketebalannya itu tambahnya berapanya.
Mr. Rido or Mr. Ginting? Okay, Mr. Ahmad Supriyadi, perhaps you will to answer the question. Okay, thank you.
Thank you for question of Dr. Imran. Yeah, in this research, yeah, I use standard of ASTM. In standard, type of sample was fixed, yeah. Yaitu 2 centimeter, and it's for all sample or species wood. Yeah. In full paper, I compare with research before, yeah. In full paper there. Thank you.
Are the results the same as tick, the class quality for machining? Is it the same as tick wood that your species?
Tick is same, yeah.
Oh, okay. Thank you very much.
Thank you, Mr. Ahmad Supriyadi and Mr. Imran. And then, unfortunately, we haven't had a response from Mr. Ginting or Mr. Rido Gulo. While waiting for them, I have questions for Mr. Wahyu Duyanto. In your opinion, will it be economically and technically feasible for potential commercial applications of densification treatment for fast-growing food in the future? And then another question is for Mr. Rudul Salam. If you go back to your fourth slide, which is about the comparisons between the two logging techniques being studied, I have a question here. At what age above the ground did you start cutting the trees? And last, for Mrs. Yelin Adalina, you mentioned that the honey water content was still higher than the maximum values allowed in SNI. What will happen to the honey if its high water content is not reduced to the value below or similar to the permissible value in Indonesian standard? Okay, so to Mr. Wahyu, while we are waiting for Mr. Gula and Mr. Giting, Mr. Wahyu, Mr. Abdul Salam, or Mrs. Yalin, I will also write down my questions in the chat room.
Your question is about the prospect of
Yes.
fast growing.
Right.
Okay. As probably we know that the fast growing species has low density. It's a low density wood, so by the densification technique, we can increase the density. We can arrange how much density we would like to achieve by arrange the compression level. For example, if we have a Sengon with the 0.3 specific gravity, probably we can compress, if we would like to compress it into 0.8, so we have to compress the Sengon more than 50% of the compression level. So probably by the increasing of the density, the quality of Sengon will be the same as Meranti, probably. Is that the answer of your question? Can I?
When I asked about the feasibility, the economic feasibility or technical feasibility in the future. I mean, we all know, I mean, like the densification treatment has priorities, a lot of positive things from that treatment, but for commercial applications by the industries, and then is it economically feasible, or what are aspects that we need to give attention to make it feasible?
Oh yes, maybe you know that we have a full-scale hot press in workshop, but now it's still broken. I mean, if investor intend to develop them, so I think we are ready to do that. Yes.
Okay, so we are waiting for the results. I mean, like for the study, the feasibility study. Yeah.
We already tried the full scale of compression wood. So I think we waiting for investor to develop. Yeah. Maybe.
Okay.
I can answer your question.
Okay, thank you, Mr. Wahyu. And then to Mr. Abdul Salam or Mrs. Yalin, which one is ready to answer the question?
Yes, thank you. Yes.
Okay, okay, Mr. Abdul Salam.
Yeah, thank you, Ms. Chairwoman, for your question. Right, there's our investigation is compared between using membuka undercut and ladder shape undercut, and the result is the difference between Humboldt and ladder shape undercut about productivity is highly significant different, but the efficiency and the residual strength, the effect is not significantly different, because less than 5% the different. I think it is so. In this case, the ladder shape type is good rather than the type. That is my answer. Thank you.
Okay, thank you. To Mrs. Yalin.
Thank you, Bu Karnita. the water content of the three types of the of bees is above standard national in Indonesia, because humidity in Indonesia range from 60 to 90%. So it's difficult to get honey with a water content that is in accordance with standard national Indonesia requirement. The higher the environment humidity, the higher the water content of honey, because honey has hygroscopic properties. One way to prevent fermentation is post-harvest handling by reducing the water content of honey through the dehumidifier. Thank you.
Oh, okay. Okay, thank you. So I think we run out of time, and I'm sorry to Mrs. Listia Mustika Dewi. I think that so far there hasn't been any response from Mr. Ginting or Mr. Widogulo, but probably you can contact them directly through email. So everyone, so this is the end of our first paper presentation session, and next paper presentation session will be chaired by Dr. Imran Arad Sofianto. To Dr. Imran, time is yours. You may start the session. Thank you.
Thank you very much, Bu Karnita. Now we start the next presentation entitled Beautifully of Transparent Biomass Composite, Simple Fabrication Methods and Visualization Under Various Lighting, Part 1. Written by Adik Bahanawan, Fauzi Febrianto, Nanang Masrusin, and Wahyu Dwianto. Please, Mr. Adik will present the presentation. He is a researcher at Research Center for Biomaterials, National Research and Innovation Agency BRIN, Indonesia, since 2015. He has published not less than 25 articles and 6 patents since 2015. He is now collaborating with universities and industries in development wood and bamboo as renewable materials for advanced materials with functional optimization on mechanical, physics, electric, and optical capability. Mr. Adik is now very busy doing research about transparent wood. Please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Adik Bahanawan from Research Center for Biomass and Bioproduct, National Research and Innovation Agency. Today, we will present
recording stopped.
Transparent biomass composite, simple fabrication methods and visualization under various lighting. This project conduct with Professor Fauzi Febrianto, Mr. Nanang Masrusin PhD, and Professor Wahyu Dwianto. Background of this research: wood, bamboo, and other lignocellulosic biomass are versatile materials. So, resource of advanced materials can be biosensor, optic material, system photovoltaic, superconductor, and etc. About optic material, we can modify and engineer the transparent composite. So, this research aims to advance material. Produce advanced material with transparent wood scheme. Wood, we have the liquefaction and polymer infiltration. So, from transparent wood, we can apply many others components like glass from wood, so it can be transmitted of the light. Biomass transparent biocomposite product, state of the art. We have many transparent wood composite, and this is our project. And methods, we have 3 kind of materials: sungkai, perennial mechanicians, hardwood, Ampel kuning bambu from Poaceae, family Poaceae. And then C4 from cornhusk. We have chemical sodium hydroxide, potassium hydroxide, hydrogen peroxide, ethanol absolute, acetone, and synthetic. Schematic of composite fabrication, we have the lignation and polymer. So we can produce a delignification wood delignification, or bamboo delignification, or cornhusk delignification. The schematic of composite fabrication, we have softening process, potassium hydroxide boiling, ethanol and acetone for leaching, and we have 2 polymer filtration with epoxy resin. And so with cornhusk sample, we have sodium hydroxide, ethanol and acetone, and transformation by composite. Measurement, we have color reader, color value, functional group, morphology, transmittance, visual underlying. Result and discussion, transparent biomass composite product. We have transparent wood biocomposite, we have transparent bamboo biocomposite, we have transparent cornhusk biocomposite. Sungai paramechanical jack with water immersion and sodium hydroxide treatment and bleaching treatment with hydrogen peroxide. We have visualization like this. Original sample, we have CLAB and CLSGE standard. For CLAB and CLSGE, the lightest are cornhusk transparent composite, high-gis A value are ampel bamboo transparent composite, high-gis B value ampel bamboo, and cornhusk, high-gis E value cornhusk transparent composite. If color change, every sample have difference is very clear from original sample. Functional group, we have many peak of this visualization. For morphology, we have polymerization, fiber visualization, bubbleization, and transmittance. Higher wavelength shows higher light transmittance value. And transparent biocomposite product under light, very beautiful. And number 1, lightening under LED lamp. Number 2, lightening under UV light. And number 3, lightening under LED smartphone. Conclusion, biomass is a renewable material that can be futurely utilized, including as raw material for the development of advanced material. Furthermore, this transparent composite can penetrate light so that it is prospectively developed into a material with optimizing its optical properties. The application, renewable optical light transparent material, photovoltaic, perovskite, solar cell material, supercapacitor, printed electronic, and sensor. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for the impressive presentation from Mr. Adik and team. Okay, we go to the next presentation with title Forensic Investigation of Various Wood Products Through Identification of Wood Species and Its Destroying Organism. It is written by Listia Mustika Dewi, Andianto, Ratih Damayanti, Jarwanto, Ayu Agustinaningrum, Gunawan Hadi Rahmanto, Rohmah Pari, Imran Arat Sufianto. And Prof. Jarwanto will give a presentation. Prof. Jarwanto is a senior researcher at Research Center for Biomass and Bioproducts BRIN in the field of biodeterioration and preservation of lignocellulosic biomass. His current research interests are on wood forensic and biodeterioration by fungi and nanopreservative. He was born and raised in Salatiga, Central Java, May 29, 1959. He was conducted his bachelor degree of Faculty of Mathematics and Natural Sciences, Universitas Pakuan Bogor. Then he continued his study on master degree at Faculty of Mathematics and Natural Sciences, Universitas Indonesia. And he pursued his doctoral degree at Applied Biosciences and Microbiology, Ehime University, Japan. Please play a video from Professor Jarwanto and team.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I would like to present my research entitled Forensic Investigation on Various Wood Products through Identification of Wood Species and its Destroying Organisms. Outlines, backgrounds, objective, material and methods, result, and discussions, conclusions. Wood is a versatile material that has been used widely for various products and utilization purposes such as buildings, ships components, furniture, and ornaments for a long time period. The diversity of wood products in the market has been increasing along with the increasing demand of wood products. Indonesia has played an important role as one of the largest tropical wood exporters worldwide. Indonesia has implemented timber legality assurance system or SPLK, which is mandatory. One of important aspects for timber legality verification is the wood species identification. Identification of wood species has become challenging aspect during verification, especially for look-alike species. Forensic investigation into wood products are frequently required to support law enforcement of the timber trade. However, the identification of wood species has become more difficult due to the poor quality of wood samples and severely damaged wood. So, the objective of the study was to investigate wood species identification of various wood products, namely plywood, decayed wood products, for forensic investigation. Two groups of materials. Group 1, wood samples were collected from damaged building component of one of embassy buildings in Jakarta, namely fences, windows, ceilings, and frames. Group 2, in the form of plywood, which requires identification to determine the commercial class of plywood products, totally 27 samples. The unsatisfactory form of wood samples and heavily damaged wood have become a challenging effort to identify wood species. We use various sectioning techniques to reveal as many wood characters as possible to identify the wood species. The microscopic slides were prepared following standard botanical microtechnique by SAS. Different processes of sample preparation for decayed wood samples were required using embedding method with polyethylene glycol to fix the samples. For plywood samples, the requested identification was the face and back layers of the plywood, as it is required for determining commercial class and taxes. The delamination of plywood layers was required to separate two face and back layers with the thickness of about 2 to 3 millimeter. The observation in this study was undertaken using face layer of the plywood. Observation of the anatomical features was carried out using a light microscope following the standard of Iowa Committee 1989. Macroscopic images were taken using a Dinolight portable microscope, while microscope images were taken using an axial imager microscope. The defined anatomical features were used for identifying wood species using wood identification program developed by Mandang and the Oxford Hardwood Datasheet. The samples were then compared to the Silarium Bogorians collection, which served as an authentic reference. Observation of and identification of wood-destroying organisms were carried out macroscopically by observing the type of attack and the Pavendam test. The method of qualitative testing of lignocellulosic enzymes produced by fungi is described by pointing. Most of the building components were using imported materials. However, they were heavily damaged after 3 years. The investigation was aiming for cross-checking the wood materials used for the building component and identify the possible cause of the damage. The result shows that from the total of 10 wood samples were various building components, 9 of them were identified as white oak, which belong to Fagaceae family. Another sample was identified as Ternguli or Johar from Pinaceae family. The damage condition of the wooden component of the building was severe, such as brittle and rotten, especially on the sun exposure areas. The building design was not equipped enough with the protection against rainwater and sunlight, as it adapted from the original country of the embassy. Laminated wood for the exterior as well as on the fence were not preserved. The fungal attack observed on the wooden component of the balcony and can be identified as Phragmites and Pycnoporus. The occurred damage became the main concern of the embassy office and for any potential danger raised as it can be collapsed at any time. The attack subterranean thermis was identified from the type of attack from the presence of a channel-like shape and the presence of soil on the white marks. The subterranean termite attack was found on the door frame of the security post. The result of Pavendam test showed that the types of fungi were white rot, brown rot, and soft rot fungi. From 27 samples of plywood, 8 different wood species were identified from the face layer of the plywood, such as red meranti, yellow meranti, jabon, pase-pase, merbatu, durian, and merawan. Examples of macroscopic features of plywood. The identification wood species from the building components were white oak and Ternguli or Johar. For plywood products, various wood species have been utilized as raw material for plywood from major commercial timber, minor commercial timber, and lesser known timber. Wood-destroying organisms that attack wood components are subterranean termite, white rot fungi, brown rot fungi, and soft rot fungi. Recommendation for selection alternative wood species for building renovation are teak wood and ironwood. This study recommended to apply wood preservation technology according to housing and building standards, change in building design, and intensive maintenance need to be carried out. Thank you very much.
Thank you very much for Professor Darwanto and team for the impressive presentation. I remind you to all the participants to give a suggestion and question to the other presenter, because your question or suggestion are very important. We go to the next presentation with the title Soreo Oxylon Fossil Wood from Flores Island and Early Record. It is written by Listia Mustika Dewi, Ratih Damayanti, Y.I. Mandang, Sri Ruliati, and Supri Hatna. Ms. Listia Mustika Dewi will present the presentation. Listia Mustika Dewi is now pursuing a doctoral degree in Melbourne University, and now she started working as a researcher focusing on wood anatomy and wood quality in Forest Product Research and Development Center FORDA, Indonesian Ministry of Environment and Forestry since 2011. She published her works on referred journals since then. She was involved in providing wood identification services in Silarium bogoriensis. And also she loves traveling and spends her free time with her family, who always been her biggest support system. She also enjoys cooking and eating spicy, yummy food. Okay, this is a good combination of a mother and a researcher. Okay, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Listia Mustika Dewi from the Research Center for Biomass and Bioproducts, National Research and Innovation Agency. Today, I'm going to present our study in investigating a new record of fossil wood from Flores Island. First of all, let me start with a brief introduction about fossil wood and why is it important to study fossil wood. This figure shows the brief process of fossil wood formation. This process began a long time ago when the trees were swept away by natural disaster like floods and then become covered by mud and sands. This condition stops the excess of oxygen into the wood so that inhibit the decaying organism in attacking the wood. From time to time, the sand layers gradually build up and minerals, mainly silica, dissolve in water, enter the tree trunk, then slowly replacing all the organic matter inside the cells. So fossil wood turn into petrified wood or silicified wood. Nowadays, we can see the fossil wood as it may be exposed by erosion, and we can still see the wood structure. So overall, this process gives an understanding that fossil wood can be used as an authentic evidence to reconstruct the vegetation in the past. The fossil wood have been discovered in some regions in Indonesia, as shown in the map here. Many wood fossils were also found abundantly in the area of Waiwul Nature Reserve Flores. However, fossil wood records from Flores Island has not been reported. Therefore, a study to investigate past florist decomposition in Flores Island was needed to reconstruct the distribution and the extinction of tree species. So overall, this study aims to investigate the botanical identity of recovered fossil wood from forests, discuss the phytogeographical aspect in relationship with the identified fossil wood, and analyze the mineralization of the fossil wood. This is the location where the fossil wood were collected in Waiwul Nature Reserve of Flores Island. For sample preparation, the specimens were cut transversely, then ground to obtain the thin section of transverse, radial, and tangential face for anatomical observation by using different sizes of carborundum powder. Observation and description of anatomical characteristics followed the IAWA list of microscopic features for hardwood identification. The result of observation were compared with the published reports with collection and reference slide collection from Silarium bogoriensis. Comparison with other fossil wood of the same genus was also investigated based on the existing literatures. In addition, mineral analysis was also conducted using X-ray diffraction or XRD, while analysis for the major and trace element of fossil wood was undertaken using X-ray fluorescence. This picture shows the anatomical feature of fossil wood from Flores Island. From this picture, we identified the fossil wood has indistinct growth ring with the diffuse porous vessel mostly solitary and axial intercellular canal in long tangential lines. From the upper arrows in tangential and radial section, we can see the diagnostic features of the fossil wood, such as fascicentric trachate and idioblast cells, which indicate the presence of calcium oxalate. Looking at the lower arrows, here we identified ray width 1, 2, 3 cells and the thylosis. Compared with extant wood described by previous studies and Silarium bogorian's wood collection, all the features show the affinities of the specimen with the extant wood Sorea, red Meranti group tribe Rubrosoria of the Dipterocarpaceae family. The anatomical characteristics were also compared with other fossil wood Soreoxylon species that previously discovered in Sumatra and Java by previous studies. This specimen could be differentiated based on the percentage of solitary vessel, tangential diameter, vessel frequency, and idioblast cell. It is therefore this fossil wood could be recommended into a new taxon, namely Soreoxylon floresiensis. For estimating the geological age, we use geological map of Komodo Quadrangle, Nusa Tenggara. The age of the formation was estimated to be Middle Miocene in the Tertiary period, which is located in the volcanic rock formation. So it is estimated that the fossil wood was living in there about 19 million years before present. The phytogeographical study showed surprising result as there were no record of Sorea species grown in Flores Island. So it's interesting to investigate why the fossil wood of Sorea can be found there. Looking at the distribution, Sorea is one of the major genera in Dipterocarpaceae, which are distributed widely in Sumatra, Kalimantan, Java, Sulawesi, and Maluku. However, Sorea does not exist in some other islands such as Nusa Tenggara, Papua, including Flores. So this map here shows that the occurrence of Soreoxylon fossil wood in Flores Island, which indicates that the ancestor of Sorea was distributed in wider areas. In addition, the presence of similar fossil wood in other big islands of Indonesia could indicate that in the past there might be a land connection from Flores Island to other islands. Regarding the possible cause of extinction, it might be caused by volcanic activities in Tertiary to Quaternary periods. For the mineralization process, the level of anatomical preservation is influenced by the relative rates of mineral precipitation and tissue destruction. The X-ray diffraction analysis showed the presence of quartz mineral as major component. The result is in accordance with the previous study that most studied fossil wood usually mineralized with polymorphism of silica such as opal A, opal C, chalcedony, and quartz. For XRF analysis, the main element in fossil wood are silica, iron, magnesium, aluminum, and calcium. As conclusions, the systematic fossil wood from Flores Island identified as Soreoxylon species, Dipterocarpaceae family, which lived in Middle Miocene period and located in volcanic rock formation. The fossil wood differs from the previous Soreoxylon species so that it can be recommended into another species, namely Soreoxylon floresiensis. The occurrence of Soreoxylon fossil wood in Flores Island indicates that the ancestor of Sorea was distributed in wider areas, and its extinction might be caused by volcanic activities in Tertiary to Quaternary periods. For recommendation, further comprehensive studies are needed to explore more information of fossil wood from Flores Islands, and the existence of fossil wood natural resources can be potentially developed to enhance the ecotourism value in Flores and its nearby island. We would like to thank Center for Standardization of Sustainable Forest Management Instrument for the support to conduct this study, the Laboratory of Geological Survey Center for providing technical support in sample preparation, and Research Center for Biomass and Bioproducts BRIN for providing funding to attend this conference and publication support. That's all my presentation. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Ms. Listia Mustika Dewi and team for the presentation. We go to the next presentation entitled Potential Utilization of Super TIC. It is written ICONLIG, G. Pari, LM Dewi Krisdianto, R. Pari, DA Agustiningrum, DSAD, IA Sofianto, Jarwanto, RGH Rahmanto. And Ms. Ratih Damayanti will give a presentation. Ms. Ratih Damayanti is a senior researcher at the Research Center for Biomass and Bioproduct BRIN. She is now, she graduated from Melbourne University, obtaining with science for the PhD. And now she is very busy doing research about wood identification using capacitance. And then she is also world-class anatomist. And in the December, she will go to the United Nations for discussing about wood forensic. So please play the video. Thank you.
Thank you, moderator. Hello everyone, my name is Rati. Today I want to share our part of study on the potential utilization of super TIC. This is the outlines from the introduction to the conclusion. And we start with why we conduct this study. Everyone, teak wood or Tectona grandis is a famous good quality timber for furniture, flooring, construction building walls, woodmaking and appearance grade veneers. But we need to wait until 80 years to get this timber, to use this timber, and the long cultivation causes limited supply of teak, and also the shortage of teak as raw material. The price of teak is high, and timber industries face difficulties in continuous supply. This condition motivates the silviculturists to establish a shorter rotation and a faster growth teaks through vegetative cultivation. And the result is the growth time decreases from 80 to 20 or 40 years enough. And now we have teak plantation that can be harvested at 5 years. One of them is famous with the name of Jun or Jati Utama Nasional. However, everyone, intensive timber production may induce changes in the economical and technical properties, and as a result, the stability of the wood for high-quality products is reducing. So, working with timber from plantation requires to make a decision when the trees have already met the minimum requirements of particular wood products. And the decision should be based on the wood properties data, not just the tree growth characteristics. So the research question, where can the super TIC be harvested and utilized at 5 years of age, and how do its wood characteristics compare to the mature TIC? And so the aim of the result or the research is to evaluate the stability of super TIC for high quality products. In this case, are veneer, furniture, and floorings. We need to answer what is the potential application of super TIC, because in the public's assumption, the super TIC is similar like fast food that have a negative image as the fast food. So we need to prove that. And for the study, we use materials of 5 years old June from two sides. It is from Bogor for the wet side and Madiun for the dry side. We have 18 logs, which were classified into 3 diameter classes, namely small, medium, and large diameter classes. And this is the requirements of wood properties for the high quality product for the furniture, Australian Timber Flooring Association, and for the veneer. The wood properties need to be analyzed, where the microscopic structure, the microscopic structure, the physical properties, mechanical properties, the durability, the machinability, the nailing properties, sanding properties, and the chemical properties. All the properties here are important to be fulfilled to know the stability of timber for appropriate products. And the methods for the veneer making, we use 3 logs because we need large diameter logs here. We only use 3 logs for each side, and we use terminal-less and rotary lathe machine. And then another utilizations, but then we can use the waste of the production from the furniture, flooring, or veneer for the pulp paper, and also for the wood pellet. We use the standards, Indonesia National Standard here, and also the standard from Brazil for the pulp and paper. The results were everyone for the furniture. According to Indonesia National Standard, the young super ticks is suitable for furniture production. The SNCE, the Indonesia National Standard require for the furniture the minimum static bending requirement for 100 kg per centimeter square or 49 MPa, and the specific gravity 0.40, and the air density of the young ticks is more than 500 kg per meter cubic. The MOE or modulus of elasticity was 8.4 GPa, and the MOR more than 50 MPa. So we can conclude that the young super tick can be used for furniture productions. However, because of its density is lower than of mature tick, super tick may not be suitable for high utility furniture such as beds or chairs, but may be adequate for office furniture such as filing cabinets or bookshelves. This is the data for the stiffness and bending properties of super tick compared to the mature tick and also another plantation tick. And for the veneer, here, mature ticks usually are in great demand for use as faceless veneer due to its beautiful figure, good quality, and can be culled without difficulty. And from the Indonesia National Standard for the tick veneer, the young super tick veneer was classified into grade C because the presence of subwood, pinhole stack, and loose knots. So from the study, we also propose a new standard only refer to the fast grown tick. For the floorings, there is no absolute minimum values for shrinkage and wood hardness, but usually the standard hardness refers to the northern red oak with the junk side hardness of more than 5,000 Newton. And set hardness of mature tick we compare, it is more than 5,000 Newtons. However, the tick and ragam also both fall into the subgroup with hardness rating in the range of 3,000 and 5,000 Newton. And the set hardness of the super tick is more than 3,000 Newton. So, even though it's lower 49% and 22% than red oak and mature ticks, but the super tick can be classified as the subflooring groups with the same classification as the mature tick and radiata pine. And then for the wood hardness, it is the data that we need to assess the suitability of the flooring, the hardness of the super thick. It's comparable for the older fast rotation ground ticks from Malaysia. And then for the pulp and paper, yeah. We compared the quality for the different sets, also different diameter class. And then the results show that the pulp pitch of the super thick comparable to the acacia medium and the eucalyptus. And then from the Indonesian Wood Paper Criteria for Paper and Paper Materials and Association of Pulp and Paper in Brazil, the pulp and paper of the super thick can be classified into class quality or group 2 with very low active alkali consumption and low kappa number. The halonic contents, however, it is 36% potentially make the timber is not favorable for chemical pulp and paper making. And then this is the chemical properties. You can see the cellulose is quite high, 42%. The lignin is also quite very high, it's more than 30%, and the extractive is 4%. And then this is the data for the fiber and vessel length that usually we need to know the quality for the making. And the last for the wood pellets, according to the Indonesian National Standard 2014, this product is recommended by as byproduct for reducing the wood waste because the super thick pass all the minimum requirements for the moisture content, volatile substance density, as content free carbon, also the calorific value for wood pellets utilization. So, the conclusions. According to the Indonesian National Standard, the young super thick suitable for furniture productions, and also for the veneer, it belongs to the grade C or the lowest grade of veneer. And according to Australian Timber Flooring Associations, the young super thicks also classify as subflooring groups, together with the mature thick and radiata pine. And according to Indonesian Paper Criteria for Pulp and Papers, Association of Pulp and Paper in Brazil, the super thick can be classified into class quality or group 2 with very low active alkali consumption. It can be classified as group 1 from the active alkali consumption itself and a low kappa number. And then according to initial standard for wood pellets, the product recommended as byproduct as the byproducts, and this is the acknowledgement for the ASEAN, Ministry of Forestry, and also BRINs. Thank you for the support. Thank you everyone for your attention. Time come to the moderator. Bye.
Thank you very much for the impressive presentation, Dr. Rati and the team. Now we go to the next presentation, R611, entitled Delamination and Bonding Strength of Cross-Laminated Timber Made from Japan Wood and Cold Setting Melamine-Based Adhesive. It is written by Yusuf Amin, Reynaldi Purnomo, Aji, Sudarmanto, Narto, Muhammad Adli Dahandiubis, Naraswara Nugroho, Effendi Tri Bahtiar, Wahyu Dwianto, and Lina Karlina Sari. Yusuf Amin, Master of Science, is a researcher in a research center for biomass and bioproduct. Now he is pursuing a PhD under supervision by Professor Lina Karlina Sari in IPB University. This presentation also will be part of his PhD thesis. So please play the video. Thank you.
Good afternoon, all participants. My name is Yusuf Amin from Research Center for Biomass and Bioproduct, National Research and Innovation Agency, Indonesia. Today, I would like to present our research with the title Delamination and Bonding Strength of Cross-Laminated Timber Made from Japan Wood and Cold Setting Melamine-Based Adhesive. Cross-laminated timber is one kind of engineered wood product made of at least 3 orthogonal crosswise layers of grade sand timber that are laminated by gluing with structural adhesive. As a building material dedicated to structural adhesive, CLT exhibits mechanical and physical properties superior to those of other engineered products such as granulated timber, OSB, and LVL, as its adjacent wood layers are assembled orthogonally. Recently, CLT has become a product of interest used in Europe, Canada, America, Australia, New Zealand, and some countries in Asia, like Japan and China. But in Indonesia, CLT is still in the early stage of development and requires a lot of research on the CLT product. One of the factors that need to be considered in the manufacture of CLT is the adhesive. The type of adhesive commonly used for the manufacturing of CLT are phenyl formaldehyde, melamine formaldehyde, emulsion polymer isocyanate, and polyurethane. The melamine formaldehyde-based adhesive is one type widely chosen by CLT or GLT producer because it is relatively cheap, has transparent bonding line, and is resistant to water and moisture. The adhesive bonds are required that are capable to transfer load and provide durable bond during the surface life of the structure. As a thermosetting adhesive, a melamine formaldehyde adhesive is generally applied to the use of hot presses, which require the additional cost for heat energy consumption. So it is necessary for innovation effort on modifying the melamine-based adhesive for cold pressing application. It is expected to reduce cost production and eco-friendly, but not reduce its mechanical strength. So this study aimed to evaluate the characteristics of delamination, bonding strength, and wood failure of the CLT product made from Jabon wood using the cold setting adhesive based on melamine formaldehyde and PMDI at the glue speed of 2050, 2080, and 300 gram per square meter. Material and methods. The Jabon wood, with the other name Anthocephalus cadaba, was collected from Bogor region, West Java, while the commercial melamine adhesive was supplied by PT Pamolite Adhesive Industry Probolinggo, East Java. The modification of melamine-based adhesive, then coded by MF1, was conducted by adding several components of the material into the commercial melamine adhesive, then coded by MF0. The industrial flour was added as a filler for the adhesive, the citric acid as catalyst, and PMDI as cross-linker at 5% and 3% based on the solid content of the control adhesive, respectively. The pH, solid content, viscosity, and gelation time were measured to evaluate the basic characteristic of melamine-based adhesive, while the DMA was performed to investigate the thermomechanical properties of melamine-based adhesive. The fabrication of CLT was referred to the EN standard with the number 16431 2021 for timber structure, cross-laminated timber requirement. The trilliard of Jabon CLT was manufactured using cold setting melamine-based adhesive and assembled in a cold press at 1 MPa for 2 hours. 3 variations of the glue split were applied. It is 250, 280, and 300 gram per square meter. The bond strength and delamination of CLT were measured referred to the N standard for CLT. Next, we move to the result in discussion. The table 1 shows the basic properties of cold setting melamine-based adhesive. From this table, we get informed that the control adhesive has higher solid content than the modified one due to the addition of a citric acid catalyst and PMDI cross-linker. The gelation time of MF0 was 5 times longer than that of MF1. The MF0 was formulated without mixing the citric acid catalyst and PMDI cross-linker, while the MF1 was prepared by incorporating the catalyst and cross-linker. Incorporating a catalyst and cross-linker fastened the gelation time process by creating a bigger polymer network. In line with the gelation time, adding 5% of citric acid and 3% of MDI resulted in a lower pH of MF1. The MF0 has a pH value of 7.67, while the MF1 has a pH value 6.67. The control adhesive has a viscosity of 484.51 millipascal second. This is indicating the viscosity of MF without a catalyst and a crosslinker. After the mixing with the catalyst and crosslinker, the viscosity of MF1 was higher than MF0 due to forming a bigger polymer network from the interaction of melamine formaldehyde, citric acid, and PMDI. The figure 1 shows dynamic viscosity and cohesion strength of cold-setting melamine-based adhesive. In line with the result of average viscosity, the dynamic viscosity of MF1 was greater than that of MF0. The higher viscosity adhesive generally have greater cohesion strength. The MF1 had a greater cohesion strength of 82 to 89 Pascal, while the MF0 had about 71 to 73 Pascal. It is expected that the CLT bonded with MF1 would have greater properties than that bonded with MF0. The higher the cohesion strength, the stronger the adhesive. DMA was conducted to investigate the thermomechanical properties of melamine-based adhesive. Figure 2 shows the DMA curve of the cold-setting melamine adhesive. From this figure, we get informed that the maximum of storage modulus 467.9 GPa was detected in MF1 at 38.4 degrees Celsius. The storage modulus tend to decrease as a function of temperature. However, this study didn't detect the maximum storage modulus of MF0, probably due to the hardening and the cross-linking reaction occurring without adding a catalyst and cross-linker. Bonding strength and delamination of the CLT. In this study, CLT bonded with MF0 cannot be produced due to insufficient curing by cold pressing. Figure 3 shows the load and displacement curve and block shear strength of CLT bonded with cold-setting melamine-based adhesive at different glue speeds. Increasing the glue speed result in a higher maximum load at longer displacement. Applying 300 gram per meter square of adhesive result in a maximum load of about 9,750 Newton at 8.3 millimeter displacement. As a result, the highest bonding strength of CLT bonded with MF1 was obtained at 300 gram per meter square of glue speed, reaching 3.14 MPa. The delamination value and wood failure percentage of CLT are presented in Figure 4 and Figure 5. Application of 300 gram per meter square of glue speed resulted the lowest delamination of 5.70% and the highest wood failure of 98.33% and met the end standard for CLT. The low percentage of delamination and high failure indicated the bond integrity of the sample test was created. Therefore, this study showed the MF adhesive could be used as a cold-setting adhesive for CLT by adding 5% citric acid and 5% of PMDI. As a conclusion, the viscosity and cohesion strength of melamine-based adhesive increase while the solid content, gelatin time, and pH decrease with the addition of citric acid and PMDI. The thermomechanical properties of melamine-based adhesive show that adding citric acid and PMDI result in the highest storage of modulus at 467.9 GPa. Application of 300 gram per square meter of glue speed could produce CLT with a better strength, delamination, and wood failure compared to other one. Melamine formaldehyde mixed with citric acid and PMDI at 300 gram per square meter could be used as a cold-setting adhesive in the future CLT manufacturing. I think that is my presentation. Thank you for your attention.
Thank you very much for your very impressive presentation, Pak Yusuf and team. So we go to the next last presentation in this session. entitled Discrimination of Conventional Infrared. It is written by Dimas Triwibowo, Danang Sudarwoko Adi, SK Himi, Ratih Damayanti, RG Harahmanto, and Sung Buk Huang. Pak Danang will give a presentation. Pak Danang Sudarwoko Adi is a researcher at the Research Center for Biomass and Bioproduct. He graduated from Graduate School of Agriculture, Kyoto University. He is expert in the application of near-infrared spectroscopy for wood products. In the last week, he just got back from the West Kalimantan to obtain the sample of bakau for his research on the near-infrared spectroscopy. Please play the video. Thank you.
Good afternoon, everyone. Today, I would like to present our research with the title is Discrimination of Conventional and Fast-Growing Thick Wood through Fourier Transform Near Infrared. My name is Danang Sudarwoko Adi. Come from Research Center for Biomass and Bioproducts BRIN as a representative of our team. Nowadays, teak is still a favorite wood for many construction applications due to its superior quality, high economic values, and also very durable compared to the other wood. However, the slow growth rotation of teak is become challenging for wood supply since this wood was cultivated up to 60 years old. Many efforts have been conducted to overcome the production lag. For instance, using a genetic improvement, shorten the growth rotation, and utilizing the unmatured wood. However, it is well known that those wood quality is very different. Fast-growing wood is dominated by the juvenile wood, which affected to the low of durability, strength, and also stabilization. In general, conventional wood identification observes the tree wood sample section by analyzing the macroscopic and microscopic characteristics. Based on the guidance of IAWA hardwood identification in 1989, there were at least 200 characters to be observed to identify the wood species. The situation leads the different results between the identifiers. On the other hand, this method is also time-consuming and labor-intensive. This situation, therefore, the alternative methods should be considered for wood identification in the near future. Near-infrared spectroscopy or NIR analysis is becoming a popular method for wood identification. NIR is the electromagnetic wavelengths between 800 to 2500 nanometer. Spectroscopy based on the absorption or emission at NIR range is called as NIR spectroscopy. This method, combined with the chemometric analysis, can be used to separate the wood species in different genera, genus, clones, or hybrids with very fast, accurate, and non-destructive result. And this is the material and methods of our study. This study used conventional, June, platinum, and community teak from different locations. Firstly, the NIR spectra were collected by performing the radial surface of the wood samples in the machine. Then, the spectra were treated to find the second derivative by Savitsky-Golay methods. Finally, a random forest classifier were applied to know the accumulation of discrimination and the chemical components which have influence to the separation. And this is the results of our study. The features of the cross-section under microscopic investigation of several thick wood. First glance, this picture is almost similar. The difference of the section is only on the different size of vessel cell or porosity. Therefore, the determination of different clones in one species is challenging due to the similarity of their characteristics. Sometimes, the general appearance, such as semi-ring porous characteristic of teak, is not visible on the all thick wood species. This picture also shows the variation of the anatomical traits on the cross-section of 8 years platinum teak. Even on the one tree, the variation of wood cell is very high. Thus, the situation makes the identification also more difficult. Teak has discrepancies in the size of the vessel and their distribution on the mature and unmature teak. And this is the NIR spectra characteristic, and the picture visualizes the original and second derivative spectra of several thick wood. The original spectra obtained directly from the machine, but the peak of spectra seems similar and only shows the difference level of the absorbance. On the other hand, the second derivative spectra shows more clearly the difference between peak on those species. This spectra is representative of some functional group of the chemical wood components. And this is the result for discrimination of fast and slow growing thick wood. The discrimination is also successful by the random forest classifier. This classifier at the estimator 11 has the high accuracy, which is reached 98%. The confusion matrix on the left picture shows there were only 8% of fast-growing wood which were misclassified as the conventional teak. The relationship between the NIR second derivative spectra and the feature importance of random forest shows the importance band affected on the model. At least there were two bands which influenced on the model. There were band at 6,000 which assigned as a lignin and 6,400 assigned to crystallization in cellulose. This is the result for the teak within a species. The determination of teak type within species also been successfully introduced. The model has 98.2% accuracy with the optimal parameter 31. The classifier called separate the June, community, and platinum teak without any misclassification. But on the other hand, there were 8% of conventional wood, teak wood, which were misclassified as a platinum teak. The second and fourth rank of the NIR second derivative spectra shows the main factor affecting to the determination. And this is the conclusion of our study. The determination of fast and slow grown as well as teak type within species has been successfully introduced with NIR spectroscopy and random forest classifier. The bands at 6,000 assigned as lignin were the important factor which influenced on the fast-growing and conventional thick determination. The second and fourth rank was the main factor affecting the discrimination of thick types. And thank you for your attention.
Thank you very much for your impressive presentation, Mr. Danang and team. So we go to the question and answer session. There are many questions in the chat room. So please answer from the first, Mr. Adi, the question you can read right in the chat room. Please answer short, concise, and clear as you can. Thank you.
Okay, thank you, Mr. M. I have two questions.
Recording in progress.
From Mr. Danang and Mrs. Alicia. Mr. Danang, is there any information regarding the thickness transparent wood in the wood quantity and forward the information? Okay. Until now, the average thickness is from 0.3 millimeter until 102 centimeter, and almost maybe about 60% research on transparent biocomposite is for alternative glass building materials, and about 30% now we deliver transparent biocomposite to but like biosensor and etc. The thickness one of transparent biocomposite delivered to biosensor, and the second question: what is the main criteria to select wood species for transparent biocomposite material from the pattern or chemical? Okay. The main criterion is the relatively low liquid content, because this lignin is opaque or impermeable to light and not too good to transmit light transmission. So the low liquid content is very preferable. And the second one is related to tangential cross section. And because of this, which are preferable to radial or transverse cross section from wood or main material like bamboo composite. And the second one, in the flaving trapezoid wood, do you expect to maintain the wood pattern after wood become? Okay, it's almost already done in this research. So it is true that one of our novelty is to maintain the distinctive pattern of cellulose material, so that is aesthetic value appears. Maintaining this pattern is a challenge because in practice it is often destroyed during thermochemical treatment, and then several studies related to transparent wood and bamboo, the characteristic feature of these materials are lost, so that the main composition that dominate is the transparent impregnant like materials such as epoxy, PMMA, and PVA, and so on. So our project still maintain and to get the aesthetic of transparent biocomposite, like in my slide presentation, the like visualization show the aesthetic of pattern of the biocomposite transfer. Maybe like this. Thank you very much.
Okay, thank you very much, Mr. Artik, for answering the question. Okay, we go to the next question from Mr. Danang to Prof. Jarwanto. Please answer the question short, concise, and clear to Prof. Jarwanto.
Okay, thank you,
Please.
Mr. Danang, for your question. But this is just to clarify that the plywood will not decay. The decay is the solid wood. But yes, it was hard to identify, as I said, very thin. We try to observe as many as characteristic we can using the high magnification. Then we also use fiber characteristic using maceration process.
so we can identify type of perforation plates and border pits. Thank you. I think that's
Okay, thank you, Prof. Jarwanto, for answering the question. And please to Miss Listia to answer the question from Pak Danang. Short, concise, and clear. Please.
Yeah, this is about the species identification. About the question is, this research found that the fossil wood is new species since there were different results with other fossil wood. How about the current wood? Is it any Soria fluorescens in Flores? So yes, so based on the distribution of Soria in nowadays, like there is no record of Soria species in Flores. So Soria is only distributed in Kalimantan, Sumatra, Java, but there is no Soria species in eastern part of Indonesia like Flores and Papua. So we recommend this discovery as new species. So there is no record of Soria trees in Flores. So that's why we propose new species like Soria fluorescensis, Sorioxylon fluorescensis, like Homo fluorescensis, if you remember about the Homo sapiens, something like that. And then the second question.
Yes, from Prof. Wahyu.
Yeah, this is regarding the technique of the sectioning. So basically, the first step is similar to the same method with the wood that we use. We have to identify the cross section first to identify the other sections. But the difference is if we can, if for wood species like normal wood, we can use one blocks to get three different sections of wood species by sectioning one blocks. But for wood fossil, we can use one blocks to obtain three different sections. So we have to make three different blocks in each section. Like we use a thin block of cross section and thin block of radial and tangential section. So. And also the difference with wood is we glued first the thin section of each section in the glass slide, and then we polish them until reach a very thin slice. So that's the overall technique to get the thin section of three different sections for wood fossils.
Okay. Thank you very much for your answer. Very clear. And then please for Dr. Ratih to answer the question from Prof. Wahyu.
Yes. Thank you, Professor Wahyu. Yeah, we tried 5 utilizations, and the best one I think is for furniture. However, this is only for like medium quality furniture, not for the high quality that should hold very high tension. For examples, not for bed or for chair that usually have a frequent burden on that. So for the furnitures, it passes all the minimum requirements from the Indonesian National Standard. And then the second is for the flooring. Because it has a good dimensional stability. And then for the less quality, the first is for the wood pellets. We can use the waste from the manufacturings of another products for the wood pellets. So that is the recommendation for the utilization of the very young fast grown teak. It is for 5 years old, but maybe if we have older trees, mature fast grown, we can use as well for the veneer. Yeah. Okay. Thank you, Co-Chair.
Okay. Is there a response from Prof. Wahyu or Ina or agree?
Ina, thank you.
Okay, thank you. Is there a question for Mr. Dana? We should have a question for Mr. Dana. Please, we should. Okay, is there? Please, participant, give a question. Come on.
Maybe about the method.
Yes,
yeah, like random forest methods. Can you explain more about this one? That's quite interesting too.
Okay, thank you. I think random forest is one of the statistical methods to know the like future important and something like that. I think it is same like KNN or SVM to differentiate maybe one or two species like that. I think it's this.
Okay, how is your response, Ms. Listia?
Yes, so to run this model, like to run this random forest, so what actually the aspect can we use to run this program? Like, is it can be applicable to like other purposes, like not only in this identification?
Yes, I think it is. We can use it for any like a spectra or other like maybe such as other spectroscopy and so on. I think it is we can use different machine like a Raman, TR or color identification, and it can be used to use random forest.
Okay, thank you. Thank you very much for your answer, Pak Danang. There is an answer for you from Dr. Ratih, Pak Danang. Okay, we go to the next question from Mr. Adi to who?
Thank you. I want to ask a question to my guest colleague, to Mr. Yusuf Amin. Okay, hello. Mr. Yusuf.
Okay, thank you.
Thank you. I have two questions. The first one is, do you use sandpaper? I think in Indonesia it's amplas, sandpaper to get maybe the robust of surface condition about your sample. Do you use sandpaper? Yes. And the second question is, I have interested in melamine because several research mentioned that melamine has great potential to become material that have fire retardancy. So what fire retardancy or flame retardancy? So what your opinion about this, and what is next project for your because this is very good product. We combine bamboo and timber to become a CLTB, cross-laminated timber. Thank you very much.
Okay, thank you, Mr. Adik, for your question. For the first, we use the sandpaper for the preparation of lamina before the glue spreading on the face of the lamina. And for question two, in this research, we not yet do the testing for the fire retardan. But in the next stage, okay, it's I think it's a good idea for the next step. We go to test of fire retardan of product by melamine formaldehyde.
Yeah, because melamine is very potential material.
Okay, I thank you.
Thank you.
Okay, thank you very much. I have one question for Pak Yusuf. Adhesive of FF1 showed 1/5 gelatin time, then MF0 6.9 to 30 minutes due to the addition of citric acid, catalyst, and PMDI crosslinker. What is the total cost of modification MF1 compared to MF0? The price for it, yeah.
Okay, thank you, Mr. Chair. I'm sorry for this research. We do not doing the calculation about the price of two different method, MF0 and FF1. But we can expectation that with the call setting, we get decrease the cost for production of CLT.
Okay, thank you very much for your answer. Okay.
Okay, thank you.
Thank you very much. I'm so sorry that the time for the discussion is finished already, and for the next discussion you can ask directly to the presenter and giving suggestion as you like. Okay, we go to the next presentation.
Recording stopped.
The entitled Determination of Three Sorea Species by Near-Infrared Spectroscopy and Anatomical Structures. It is written by Rohmah Pari, Ayu Agustiningrum, Danang Sudarwoko Adi, IA Sofianto, Jarwanto, RG Rahmanto, R Damayanti, Setiawati, SH Wang, C Oktaviani. Mbak Ayu will give a presentation. Mbak Ayu is a new researcher in a research center for biomass and bioproducts. Now he is pursuing a doctoral degree focusing on the research about non-destructive measurement on the wood products using capacitance under supervision of Dr. Warsito Purwotaruno. Please play the.
Good afternoon, ladies and gentlemen. I am Dia Ayu. Let me present to you a study that has been conducted by my team entitled Determination of Three Sorea Species by Near-Infrared Spectroscopy and Anatomical Structures. This is the outline of my presentation. There are introduction, materials and method, results and discussions, and conclusions. The background of this study is there are many species of Sorea we have here in Indonesia and which have different prices due to the species itself. We know that the higher the price, the higher the tax as well. So in some cases, the importers sometimes make false declarations to reduce their tax bills. Thus, what identification is important for monitoring the timber trade to prevent the misclassification as well as document falsifications. But identification method that we commonly use is conventional, which is time-consuming and needs specialized expert on wood anatomy. And this is rather difficult to be done on site. The current research is using non-destructive or NDT approaches to identify wood species due to the benefits such as the rapid, portability, and easy to use. From several NDT methods, the use of near-infrared spectroscopy or NIRS may be utilized for the on-site identification on wood. The objective of this research was to determine of three Sorea species using NIRS and compared to the anatomical properties. The wood samples we used was from the authentic collection of Silarium bogoriense, Indonesia, namely Sorea reprosula, Sorea bracteolata, and Sorea parvifolia, in the form of blocks, and the dimension was 1 cm along all sides, transversal, radial, and tangential. In this study, we used NIRS and multivariate analysis. We used Perkin-Elmer spectrum FTIR to collect spectral data for each side. After we have the signal data, then we analyze the data by principal component analysis or PCA as pre-treatment and statistically filter to smoothing the data. Then, we classify the data by K-nearest neighbors or KNN and support vector machine or SVM classifier. For the anatomical structures analysis, we use the microscopic sections of each site by a sliding microtome and identify it under the microscope. This is the result from pre-treatment process. From the raw data, we collected at the width number 10,000 to 4,000 centimeters. Then we trimmed by PCA to collect the data region that represent the wood characteristic, which is 8,000 to 4,000 centimeters. Then we use Savitsky-Golay filter to reduce the noise data, to smooth it out, and to obtain the second derivative. Data analysis then continued by classification using KNN and SVM. From those both classifiers, we can see the difference how to differentiate the SORIA samples. The accuracy of both algorithms was approximately 67%, which is relatively low. KNN provides recognitions of SORIA parvifolia at high accuracy, yet cannot differentiate between SORIA leprosula and SORIA bracteolata, while the SVM approaches better at recognizing SORIA leprosula and SORIA bracteolata, even the matrix score was low. The SVM is probably better at classifying because it does not require a complicated data processing like KNN. The species identification by SVM was presented at normalized confusion matrix. The SVM was able to classify SORIA parvifolia for 75% and SORIA bracteolata for 67%. The problem was SVM failed to differentiate between SORIA leprosula and SORIA bracteolata, which is the score was 50-50. The samples that we use, SORIA parvifolia and SORIA leprosula, is included as red Meranti, and SORIA bracteolata is categorized as white Meranti. Through the anatomical properties identification, we could obtain any information about wood distinctive characteristics. In the radial sections, we found prismatic crystals in non-chambered and chambered axial parenchyma cells, also crystals in enlarged cells, which is the main characteristic of red Meranti, while at SORIA bracteolata, crystals were absent. But silica bodies in the raised parenchyma did exist, which is the one of the distinctive characteristic of white Meranti. From this study, we can conclude that anatomical structures observation was still preferable for differentiating SORIA wood up to species, since this conventional method allows for direct investigation of the distinctive characteristic of each wood species. However, the observations were destructive, so it was time-consuming, expensive, and required specific knowledge of anatomy. NIRIs is feasible to be used considering the non-destructive method is rapid and handy, so that is easier to use in the field. In the future, NIRS can be upgraded by increasing the quality and quantity of the spectral databases and enhancing algorithms to improve the identification accuracy. That's all about my presentations. Thank you for your attention. We look forward for your feedback. Good afternoon and good day.
Thank you very much for Mbak Ayu for your impressive presentation. We go to the next presentation, also from Mbak Ayu. Mbak Ayu will give a presentation entitled "A Study of Discoloration of Untreated 5-Year-Old Fast-Grown Big Wood." It is written by Dia Ayu Agustiningrum, R.G. Rahmanto, R. Pari, I.A. Susianto, Jarwanto, and Rati Damayanti. Mbak Ayu is during busy with research and school for PhD. Her hobby is also running. Okay, please play the video. Thank you very much.
Good afternoon, ladies and gentlemen. I'm Dia Ayu. Today, I'm representing Mr. Gunawan for the presentation. Due to his health condition, that does not allow him to present by himself. I would like to present our study entitled Study of Discoloration of Untreated 5-year-old fast-ground teak wood. In this presentation, I would like to share with you about introduction, materials and method, result and discussions, and conclusion. The background of this study is teak wood, a genus that widely utilized for many purposes, such as for furniture, construction, and etc. However, teak wood has long rotation, which is generally obtained when it has reached 80 years, and these conditions make the prices of the teak wood have risen tremendously. Due to the high demand, the researchers used to study to short the wood rotation and accelerate the teak growth, one of which is Jati Unggul Nusantara or JUN. Teak wood's market value has increased due to its distinctive color. Thus, understanding the color changing is the key problem in raising the added value of wood. The research objective was to observe discoloration of untreated 5-year-old fast-ground teak wood board that have been displayed indoors for 8 years. The material observed in the study were 5-year-old fast-ground teak wood in the form of board that have been observed before. The boards were built from teak wood from wet and dry side, and from 3 diameter classes. To collect the color data, we use color reader Konica Minolta CR10. We also measure the room temperature using digital relative humidity thermometer. This is the procedure of color measurement. We use CLAB color systems. There were 3 color parameters that we observed, namely L for whiteness, A for redness, and B for yellowness. The measurement results were then analyzed using the following formula to obtain the gap of color difference or delta E. Compared to previous measurement quantitatively. The color value then compared to the data from previous measurement statistically by Wilcoxon match pair test to verify the wood color difference during display. This is the appearance of teak wood board that we observed. We can see here there are softwood and hardwood. The color data we observed was from both softwood and hardwood. The total color difference were calculated by the average of color value on each board. In the table, we can see the total color value of L, A, and B at 2014 and 2022. For the total color difference, we obtained 22.9, and for the delta L was minus 18.4. Based on the GLAB diagram, minus here means that the color of L is decreased, so it turns into darker. For A color was positive, it means the color turned into redder, and B also positive, it means the color turned into yellower. According to previous research by Koch, the wood discoloration during storage brought about by parenchyma cells that are still alive reacting physiologically. The yellowing of wood during storage is also caused by biological processes. When wood is stored, the stain's intensity is influenced by the wood's moisture content, how long it is exposed to air, and the temperature outside. This is the result of Wilcoxon sign rank test. For the L value, the sign significance of all boards will all lower than alpha 5%. It means that the color of L between 2022 compared to 2014 was significantly different. The same result for A value is the same as L. The assigned significance for all boards will all lower than alpha 5%. It means that the color of difference between 2022 compared to 2014 was significantly different. Different results shown for B value. For thick wood board built from small diameter teak from side 2 on the hardwood, the assigned significance was higher than alpha 5%. It means that the color is not significantly different. This may occur because in the Wilcoxon test, what is tested is the difference in color trend changes, whether positive or negative. For the raw data of the B value for this board, the ratio between positive and negative color data is almost the same. So, statistically, the color changes is not significantly different.
Sudah bilang.
The conclusion of this study was during indoor display, 5-year-old passed from thick change color to darker, redder, and yellower. Discoloration can occur due to external factors such as exposure to sunlight and air. In addition, there are also internal factors, namely the physiological process of the wood itself due to the moisture content. That's all about my presentations. We look forward for your feedback. Thank you for your attention. Good afternoon.
Thank you very much for Mbak Ayu dan tim for your expressive presentation. Now, before we go to the next presentation, I remind you to give a comment, suggestion, and question for the other presenter because they are very important for improving the research. We go to the next presentation entitled Physical and Anatomical Properties of 9-year-old Platinum Thick Wood. It is written by Teguh Darmawan, Narto Sudarmanto, Dimas Triwibowo, Yusuf Amin, Adik Bahanawan, Danang Sudarwoko Adi, Imran Arad Sufianto, Prabu Setria Sejati, Wahyu Dwianto, and Imam Wahyudi. Pak Teguh Darmawan will give a presentation. He was born in Ngawi, 1982. He got the master degree by research program in science and forest product technology IPB University. He started working at the National Research and Innovation Agency Indonesia since 2005. The focus of his research area is the basic properties and wood properties enhancement. He is expert in wood physics and mechanical. Please play.
Assalamualaikum warahmatullahi wabarakatuh. I am Teguh Darmawan from Research Center for Biomass and Bioproduct, National Research and Innovation Agency. In this session, I will present our research with title Physical and Anatomical Properties of 9-year-old Platinum Thick Wood. The background of this research is thick wood is one of the important types of wood in the timber trade in Indonesia. However, the stock of teak from the forest is decreasing because it has a long rotation. In addition, the demand is increasing, so that teak becomes rare and the price is expensive. This research is a series to observe the basic properties of 9-year-old platinum teak, especially the physical and anatomical characteristic. It is important to determine the basic trait of this wood, so it can be used to utilize properly and as an input for the development of platinum teak in the future. Research methods. This study used 9-year-old platinum teak. This teak was developed by National Research and Innovation Agency in the Cipinang Bogor area. The characterization of physical properties of 9-year-old platinum teak sample includes measurements of density. Measurement of the distribution of wood density will carry out radially. Subwood-hardwood proportion. This measurement based on the ratio of the area of the subwood and hardwood in the transverse section. And then dimensional stability. This is a shrinkage measurement. Samples were taken from 3 positions, namely subwood, hardwood, and the subwood-hardwood transition area. Measurement of shrinkage in the longitudinal, tangential, and radial direction. Wood color. Observation of wood color on the subwood and hardwood on the tangential surface of the wood. Observations were made in air-dry conditions. And anatomical observations, microscopic sections were taken from the hardwood part. Samples were cut with a rotary microtome to obtain cross-section, radial and tangential. Anatomical features were analyzed according to International Association of Wood Anatomists list for hardwood species. And this is the result. Density, measurement of wood density in the radial direction, so an inhomogeneous distribution as shown in the figure. Density was lower around the pit and increased in the subwood near the back. The density of this stick was about 0.5 until 0.56 gram per cubic centimeters. In the table, the density of several thick wood are shown for comparison, including the density of thick platinum 9 and 5 years old, commodity thick, and paternity thick. The result of this study indicate the density of 9 years old platinum thick is in accordance with the report range. However, the density value is still below the density of paternity thick. Subwood hardwood proportion. Proportion of subwood and hardwood are 45 and 55% respectively. This value is slightly better than the proportion of subwood and hardwood of other fast-growing thick as shown in this table. But this hardwood portion value is still below the density of conventional thick. Dimensional stability. The dimensional stability of platinum thick 9 years can be seen from the value of shrinkage in the longitudinal, radial, and tangential directions. The TR ratio range from 2.4 until 2.9. The hardwood areas are slightly better than the center and subwood area. There was an increase in radial and tangential shrinkage when compared to the younger thick age 5 and 8 years. TR ratio is still above 0.2. It is possibly caused by the age factor of the tree. The sample used in this study was relatively young, and the literature states that it had a small proportion of mature wood cells. This is platinum thick color. In general, platinum thick has bright color in the subwood, which is light in color, slightly white, tend to light yellowish brown. In addition, the hardwood is dark with dark brown. The hardwood has a non-uniform brightness because the outside is darker than the inside. The color value of platinum thick based on the C-lab color space is shown in table. The highest lightness value start from subwood, inner hardwood, and outer hardwood parts. In general, the color value of platinum thick is the same as other fast-growing thick. Anatomical observations, macros and microscopic observation. 9 years old platinum thick are shown in figure. The vessel is arranged in a ring porous and sometimes a diffuse. Vessels are generally solitary and cyclically joined by 2 up to 3 cells. The image shows the presence of telosis. The simple perforation plan has bit between alternate vessels. The characteristics of the ray are homogeneous, uniseries to multiseries, 1 up to 4 series, composed of horizontal cells. Axial parenchyma is seen in the growing circle. The fiber length, diameter, and wall thickness also in table. The fiber quality of 9 years platinum thick is in class 2. More complete anatomical features are shown in table. In general, this anatomical feature is in line with previous research on 5 and 8 years platinum thick, as in part vessel, tissue proportion of parenchyma, vessel, array, and fiber. And this is the conclusion of this study. Thank you for your attention.
Thank you very much for Pak Teguh and team for the impressive presentation. We go to the next last two presentation with the title Performance of Low Molecular Weight of Phenol-Formaldehyde Impregnation Woods on Dimensional Stability and Durability Against Termite. It is written by Sarah Agustina, Wahyu Dwianto, Dimas Wibowo, Imam Wahyudi, Iwayan Darmawan, and Jamaluddin Malik. Mbak Sarah will give a presentation. Dr. Sarah Agustina is a postdoctoral fellow at Research Center for Biomass and Bioproducts BRIN since July 2022. She graduated from Department of Forest Products Science and Technology, Faculty of Forestry and Environment at IPB University. Sarah's current research are mainly on research and development of interior products from fast-growing wood species through combination method with low formaldehyde emission adhesive. She is very busy, coming every day to the integrated laboratory of bioproducts. Please play the.
Good afternoon. I would like to introduce myself. My name is Sarah Agustina. In this moment, I would like to present our research work related to dimensional stability and durability against termites of wood impregnated with low molecular weight phenol-formaldehyde. For the background, as you know that wood is heterogeneous biomaterial that its dimensional stability and durability are insufficient for long-term application. Therefore, numerous research have developed a variety of countermeasures. Wood impregnation has been one of the most discussed techniques and has continued to garner increased interest. This process involves treating wood with a monomer or impregnating agent that is used into the cell walls, followed by polymerization to alter wood's desired properties. This process can be grouped into two mechanisms: active modification by cross-linking and passive modification by cell wall bulking. The wood has been impregnating by many impregnating agents. Among them, thermosetting resin is still a preferred choice for variety manufacturing engineering wood products. It has several advantages such as good moisture resistance, superior mechanical electrical properties, and good heat and flame resistance. However, PF treated wood could have resulted in poor penetration on nanometer scale due to its high molecular weight, which can make a negligible effect on the dimensional stability and decay properties. Therefore, low molecular weight PF is one of the solutions to overcome this limitation. The characteristic of low molecular weight PF differs from conventional PF, particularly in terms of molecular weight, solubility, penetration, and durability distribution. According to previous studies, low molecular PF is composed of small oligomers that can easily fit into small cavities, can penetrate the wood more easily, depositing almost entirely in the cell walls with little or no deposit in the cell cavities. This has a significant effect on dimensional stability and durability against biodegradation agents. From those explanations, therefore, the study evaluated the effect of low molecular PF treated wood, particularly in lower concentration levels, on dimensional stability and durability against termites. We move to the next section, methodological section. The main material were the logs of nyatok, sepetir, and pisang putih. The logs were converted into 2 x 2 x 2 cm cubic wood samples. Impregnating agent used was low molecular weight PF, produced by Sumitomo Bakelite with the specification as mentioned below. Impregnation process was conducted by vacuum pressure method. The procedure began by placing samples in low molecular weight PF with 7, 8, 9, 10, and 11 concentration, vacuuming for 15 minutes, applying pressure, followed by hot immersion, oven dry, and conditioning, finally conditioning, and testing the treated sample. Testing parameter including weight percent gain, swelling coefficient, anti-swelling efficiency, water absorption and thickness swelling, weight loss, and mortality against biodegradable agent were analyzed. And also treated wood were characterized using scanning electron microscopy in order to observe the microstructure changes. And the various impregnating agents were analyzed using IBM XPS as statistic. Significant difference compared by a two-tailed group t-test at 5% significant level. And we move to result and discussion section. The dimensional stability of treated wood can be approached by coefficient of swelling, anti-swelling efficiency, water absorption, and thickness swelling values. The average values of each parameter are presented in this following table. The result shows that seperti resulted in better dimensional stability improvement than other wood species. It can be seen that treated wood had a lower coefficient swelling, reduced by 9 until 30%, and higher anti-swelling efficiency around 12 until 30% compared with untreated. The coefficient swelling values tended to decrease as concentration increased. Meanwhile, the inverse phenomenon occurred in anti-swelling efficiency values. It can be proven by correlation between those values and concentration as shown in this graphic. In addition, water absorption and thickness swelling values for treated wood reduced by 3 until 44% and 15 until 34% respectively from their untreated. Those values tended to decrease as the concentration increased. It can be proven by correlation between those values and concentration as shown in this graphic. Those moderate R-square values indicated that the correlation were quite significant. This phenomenon is closely related to its weight percent gain values. Treated wood could give weight percent gain around 2 until 6%. It also evidenced by some observation. It can be seen that low molecular weight PF compound was able to partially cover up the vessel and fiber cell at 7% concentration, and its role as blocking agent was increasingly seen as the concentration increased. This could be due to the increasing number of area that were completely covered by impregnating agent. The more area covered would make it difficult for water to enter or fill up the cell cavities of wood, thus eventually increase dimensional stability of treated wood. Correlation between anti-swelling efficiency and water absorption values with weight percent gain serve as evidence for this finding. Those moderate to high R-square indicated that the correlation were quite significant. Next, we are going to talk about durability against damage, which can be approached by weight loss and mortality values. From this table, it can be seen that Sepetir had slightly lower weight loss values and higher increase of mortality than others. This supported by the higher weight percent gain values produced in this wood species during the impregnation process. It also can be seen that treated wood had a lower weight loss, reduced by 26 until 83% compared with untreated, with mortality around 100% in each treatment, meaning that the termites were completely dead. The weight loss values tended to decrease while mortality tended to increase as the concentration increased. A significant correlation between those values and concentration serve as evidence for this finding. According to Standard Nasional Indonesia, 3 wood species have increased their resistance class from 3-4 to 2. Treated wood tended to increase resistance class as concentration increased, becoming durable class 3 at 2 and 1 for 7 and 11 concentration respectively. And for those results, we can conclude that lower flow rate phenylformaldehyde treatment resulted in an improvement on dimensional stability and durability against termite in all wood species. Seperti treated wood resulted in better improvement in both properties than other wood species. Treated wood could give higher weight percent and lower coefficient swelling compared with untreated, as well as anti-swelling efficiency value ranging from 12 until 30%. Water absorption and thickness swelling for treated wood reduced by 3 until 44% and 15 until 34% respectively from their untreated. Treated wood tended to increase in durability class as concentration increased, becoming durable class 2 and 1 for 7 and 11 concentration. This is the references I've used in this research, and thank you very much.
Thank you very much to Mbak Sarah and team for the impressive presentation. We go to the last presentation entitled Recovery Rate and Physical Properties of 32 and 37-year-old sound oil palm trunks. It is written by Jamal Balfas, Desi Rahmi Trisatya, and Rohmah Pari. Pak Jamal Balfas will give a presentation. Jamal Balfas is a researcher at a Research Center for Biomass and Bioproduct, BRIN. He was graduated from the Australian National University in Canberra. His current research are mainly on functional materials derived from lignocellulosic materials, particularly on oil palm trunk. I heard that Pak Jamal Balfas is expert for the oil palm. Please spray.
Good day, ladies and gentlemen. My name is Jamal Balfas, working at the National Research and Innovation Center. I would like to share the result of a study regarding the recovery rate and the physical properties of 32 and 37 years of sound oil palm trunks. The Oil Palm Plantation and Industrial Development Program has been a national agenda which involving several ministries and institutions, including the Ministry of Environment and Forestry. Largest portion, more than 70% of tree waste generated in replanting is consisted of oil palm trunks. The most effective way to avoid burning and pest infestation in oil palm replanting practices is to utilize maximum portion of waste generated during replanting. Oil palm trunk is a monocot which has relatively inferior physical and characteristics compared to commercial wood. A wide range of studies show that OPC has a potential to be utilized as alternative wood material by applying the processing and advanced modification of wood technology. This study was aimed to analyze the recovery rate and physical characteristics of mature OPC of the 32-year-old and 37-year-old oil palm trunks. The method is the logs of the oil palm trunks were cut using benzol mill, 44 inches, using the power of 60 power horse. The 32 and 37-year-old oil palm trunks were collected from Lampung, Banten, and West Java provinces in Indonesia. The oil palm trunks were cut into 3 parts, which were bottom, middle, and top portions. These parts were cut to the required size for physical properties tests. The physical test carried out in this study was referring to ASTM D4292 for moisture content and the STM D23914 for the density and specific gravity. The specimen dimension was 5 centimeter by 5 centimeter and 5 centimeter. 3 replications were made for each group. Results of this study show that log taper of the 70-year-old was higher than the 32-year-old, and the length of the 70-year-old of the trunk is bigger than the 30-year-old, and we can also see that the mean values of several characteristics of oil palm trunks. The bottom diameter is bigger than the younger ones, and the upper diameter is similar, and but the diameter at breast height is also similar. We can see that the log length apparently had significant influence on recovery rate for medium and hard portion of the log, and significant proportion or soft portion of the log. The recovery rate in the present study, however, were similar to the recovery rate of OPT in the previous studies. In the absence of specific regulation of on sound OPT, the Directorate General of Forest Industry Management has stipulated the regulation and the recovery rate of primary wood processing industry. Referring to this existing regulation, the recovery rate of sound OPT was in the range of recovery rate of sawn timber from plantation forest. It is 40% to 65%. The fluctuating trend of moisture content values in this present study was similar to the previous studies. The tree portion and its morphological characteristics were found to influence the OPT physical properties. The moisture content value had a positive correlation with cellulose content of the OPT vascular bundles. Similar to moisture content value, the difference value of density in the longitudinal direction was attributable to the characteristic of vascular bundles. We can see that the mean values of physical properties of specific gravity of solid oil palm trunks was higher in the bottom and going lower to the middle and similar to the top. And we also see that the density of the oil palm trunk shows similar phenomena with the specific gravity. The recovery rate of oil palm trunk was found influenced by the log taper, diameter, and age of the oil palm trunk. The 37-year-old oil palm trunk had better recovery rate and physical properties in comparison to the 30-year-old oil palm trunk. The application of processing technology should be carried out to improve the performance of oil palm trunk as a promising wood substitution material. I have to acknowledge the research of this study was funded by the Ministry of Environment and Forestry for supporting and facilitating the study. Thank you.
Thank you very much for Pak Jamal Balfas and team for the impressive presentation. Now we go to the next session is a discussion and a question and answer. There are already 2 questions for Pak Teguh, but unfortunately Pak Teguh cannot join now because of the family interest. So our team like Pak Yusuf and Pak Danang will answer the question. Maybe in this room we'll have a direct question. Is there? Raise your hand, please, before we go to the chat. Please, is there? Come on. Oh, Mbak Sari. Yes, please, Mbak Sari Delviana. A question for who and short, concise, and clear. Please.
Okay. Can you hear my voice, co-chair?
Yes, it's clear. Yes, please.
Okay. So my question goes to Mbak Dia. So your presentation was amazing. So that's why it raised my curiosity. So for
Recording
your
in
presentation,
progress.
for the first presentation, you conclude that NIRS can be an alternative wood identifier instead of the manual microscopic structures identification. But for the result, generally we can see that both of KNN and SVM has its limitation to separate those 3 Sorea species, right? So my question is, what is the condition or what is the time we can still rely on the NRS, or for example, for a study case, we conclude that, oh, let's do it by using the NRIS, or another study case, we cannot do that because we have to do the identification, the manual identification. Thank you.
Please, Mbak Ayu.
All right, thank you. Thank you. Can you hear my voice?
Good.
Oh, okay. Thank you, Mbak Sari, for the question. Yes, NIRS can be considered to identify the woods compared to anatomical microscopic investigation. But well, yes, indeed, in our research, there are any limitation in the results. So the accuracy is still relatively low. Actually, this depends on the condition from the observation itself. While we trying to obtain the spectral data using an IRS, we realize that our sample dimension is too small. So it was still too little compared to the sensor itself. So for the next results, we will try to the bigger size for the samples, and also the limitation of sample we have here. And IRS works well if we have as much as databases for each sample. So the comparison between the spectral for every samples will be more accurate. Maybe from our research, previous research is the sample is too little. We need much sample we used to investigate using NIRS. But thank you. We will consider it to the next research. Thank you, Mbak Sari.
Okay, thank you very much for your answer, Mbak Dia. Is there a response from Mbak Sari or Ina?
Okay, so maybe I wanted to confirm. So the result from your research, I mean, like there is a limitation because of the limitation of the condition of the sample in your research.
Yes, I think. Yes, we think one of the factors that the result is that the accuracy relatively low is the one of the factor is the sample's conditions.
Okay, thank you.
Okay, thank you for your confirmation.
Mr. Moderator, maybe I can answer the question from
Oh yeah, yes. There is a Prof. Wahyu who also including in the
Malaysia.
team. Yes, please.
From Malaysia, yeah. About the platinum tick. Can I answer?
Yes, Professor, please answer the question. Also from Mbak Sarah.
Yeah, actually, platinum tick has developed since 2006 by Research Center for Biology and Biotechnology, at that time Indonesian Institute of Science. And then platinum tick is a mixture original introduced by uncharacterized mutant induced by gamma irradiation tissue culture, derived from the introduced tick genotypes. I read this statement because it will be published in first ICONLIG. This statement is from the researcher from biology named Dr. Wicaksono. So this mutant and the introduced clone were then propagated using tissue culture technique. I think that I can answer.
Again, Prof. Wahyu, please. Question from Mbak Sarah.
From Sarah, okay. I think Teguh has already done the right thing. He took the sample from the bark into the pits, as probably you can see the material and methods. Also, he used the same sample for measuring dimensional stability and density, but in this case, he more focused on the teras and kok lupa saya.
Hardwood.
Hardwood and hardwood.
Yeah. He focused on that both different wood. Okay.
Okay, thank you, Pak Wahyu. But based on the figures that is shown in the presentation, it's like 1 for density, 2 for what I forgot for the 2, and the third is for dimensional stability. That's why I asked the question, did he took the same sample for density and dimensional stability like that? Thank you.
Pak Imron, can I add more information?
Okay, please.
Okay. This is because we have two different size of this stability dimension and density, because we measure the density based on the growth ring, and then for the stability dimension, we would like to know about the difference, the stabilization in the hardwood or in the softwood. So we separate the samples based on the size. So we cannot measure the dimension stabilization stabilization and the density in the same sample. I think it is different.
Oh, I see. Thank you for the information. Now I understand. Thank you.
Okay. Thank you very much for your answer, Pak Danang. Is there one question? I give one chance again. 1, 2, 3. Okay, there is no question anymore. Okay, thank you very much for the presenter from 1:30 until now. Give applause to us. Okay, very good discussion, and thank you very much for the suggestion, comments, and question. It will improve the research. Thank you very much. I return to Bu Karnita to close. Thank you very much.
Thank you, Dr. Imran. A very interesting session that we have today. So, ladies and gentlemen, finally, we are at the last moment of our parallel sessions for today. I would like to thank you to all presenters, participants, co-chair, IT team, and event team for building an interactive session and such a joyful environment for this afternoon. And the second ICONLIG 2022 will still continue tomorrow. The conference link and registration will be open at 7:30, and you will find the link in your program book. During the closing ceremony session tomorrow afternoon, we will give award to the best presenter. So please try your best to attend tomorrow's event too until the end of the conference. And before I close the session and we all leave the room, we will have our very last photo session for today. So to everyone in this room, please turn your camera on from now. I see many names appear only in my screen, but not their faces. So please don't be shy to show us your face. Please turn your camera on. And to Budia, please give us signal when you start taking our picture.
Okay. But we still have several presenter or participant still turn off their camera, or we can screen capturing. We continue or we wait, Dr. Kanita?
So we wait for another 1 minute, and then if they don't turn on the camera, and then we can continue. 1 minute from now.
From now?
Yeah.
Oh, okay.
Then you can start taking our picture after that.
Okay.
We still wait for the participants who haven't turned on their camera on.
Oh, I think almost all the presenters did already. They already smiled, Dr. Kanita. So I think we can screen capture for now. Yes. All right. I'll count to 3. For the page 1. 1, 2, 3. All right. Hold on. For the next page, please give me your best smile. You know that it's already noon. Okay, smile. 1, 2, 3. Thank you very much.
Okay. Okay, thank you for your participation again, ladies and gentlemen. We are looking forward to seeing you again tomorrow, and have a great rest of your day. Thank you. Bye-bye.
Thank you, everyone.
Thank you. Thank you, everyone. Thank you.
See you tomorrow.
For the presenter who haven't got the question,